So I'm with Alberta Eco Trust. Actually, just before that, so if you didn't see, washrooms are just out in the lobby to the left there. We're gonna have a couple short presentations or a couple formal presentations this morning, and then we'll have a chance to go over and interact with the wall library and just ask questions from the different people who are here today participating with us. And yeah, so we're gonna get going. So we're Alberta Eco Trust. We're here today presenting with Retrofit Canada. Alberta Eco Trust, we're a charity that leads and supports environmental initiatives throughout Alberta in a bunch of different fields. I'm going to talk a little bit about our actual buildings initiatives today, but we have a 30 years of operation in Alberta, mostly as a granting agency. We would grant to other environmental action groups to support them. And more recently, we've expanded, doing a lot more direct action and expanding our team. Just a reminder, so we will have a photo release today, or I shouldn't say we'll have photo. We're going to be taking some photos today. If that's an issue, just find one of the ENBIX staff, so myself, Kate, or Alicia at the back there. Oh, I only have my name tag on it this morning. just falling apart up here. We are also, so this is a hybrid session, so we are going to be recording the Zoom recording portion of it for Stefan's presentation. Same with. You'll see that we do have some Q&A functions for that, so we'll be able to ask some Stefan some questions, but we are recording that, so you're aware. So Alberta Eco Trust operates all across Alberta. We recognize the traditional territories of many diverse Indigenous peoples, including Treaty 6, 7, and 8 nations, the Blackfoot Confederacy, including the Siksika, Kainai First Nations, the Cree, Dene, Nakota Sioux, Saulteaux, and the Métis Nation of Alberta. The Indigenous lands have been stewarded for many generations by the Native peoples. And with Alberta Eco Trust, we work with the built environment, and we work on the impacts that the built environment has on the rest of our environment. And so there's a real connection there for us to continue that stewardship and make sure that we are managing our resources sustainably. A couple of thank yous this morning. I want to thank Retrofit Canada for helping co-sponsor this presentation. We work closely with Retrofit Canada. We work across the retrofit and the new construction space, but when it comes to the retrofits, we like to work really closely with Retrofit Canada because that's their specialty. So Tim is around here somewhere. Tim is at the back there. So if you have questions about Retrofit Canada, you don't flag him down. And he's done a really wonderful job of helping us promote today. So please do go to Retrofit Canada if you're unfamiliar with them. Also LEEP. LEEP is Local Energy Efficiency Partnership. They are the ones who have prepared the materials today and supported the case studies that we're going to see. Couple things today, so make sure that you have registered with us today. We're going to do a giveaway from Built Green Canada. So Built Green Canada has kindly offered a 2 prize packages. One is a membership certification bundle and one is a training package. So as long as you're registered, I will enter you in that today, and I will do that draw probably after today's event. And in addition to that, LEEP has generously given us a hardbound copy of the Net Zero Wall Guide assemblies. So we will give a copy of this away today too. I will try and do that before we conclude today. That requires a lot of organization on my part. So do make sure you're registered, because that's what I'm going on for. So I mentioned before, Alberta Eco Trust, we have our parent organization, and then we have our buildings initiatives. That includes 2 programs, ENBIX, we are the Emissions Neutral Building Information Exchange, you know, it's a mouthful. And then we're also the Retrofit Accelerator. There we go, thank you. So ENBIX, so we work with industry across the construction world. So part 3, part 9, new construction, renovation, doesn't matter. We work on events like this, we work on training, resource development, information sharing, any way that we can act to support industry to promote energy efficiency and emissions reductions from the built environment. Our sister organization is the Retrofit Accelerator. So whereas ENBIX, we focus on the construction industry, ENBIX or Retrofit Accelerator focuses on owner operators on coaching services for deep energy retrofits. They also work with industry to try and build out the network of companies that can actually offer deep energy retrofits. So lots of information on our website about both of these organizations if you have questions. We have a partnership with Carbon Leadership Forum Alberta. CLF is a part of an international group that works on embodied carbon. Quick show of hands, everybody familiar with embodied carbon? You? Okay, so if you're not familiar with it, When we talk about emissions from buildings, we talk about operating emissions, so that come from the energy we consume at the building. Embodied carbon is the emissions that go into the construction practices. So construction, renovation, materials, transport costs, all of that shows up in the embodied carbon. An increasingly important topic. It likely going to show up in future code cycles that will start to see embodied carbon topics showing up and awareness of that. So we're trying to seed the ground in Alberta early, and CLF works entirely on embodied carbon issues. If you like today's event, please check out our events calendar. We host many more events like this. We do have a very active events calendar. It hosts not only our content, but it hosts content from other organizations. There's oftentimes I've seen where you will see, you know, every weekday of the month populated by somebody's event, all focused on energy efficiency or emissions reductions, training, services, networking opportunities. We also maintain a resource library, so we develop some of our own resources. We showcase resources from other organizations like Retrofit Canada. We showcase policy pieces for municipal people. Really spans the breadth of topics. Everything, though, is curated for an Alberta audience. So we are an Alberta-focused organization. So anything we post to our resource library, it's because we felt there's relevant to an Alberta, somebody in Alberta, whether that's, you know, utility rates, climate zone, something that makes sense. We also prepare a synopsis for every resource we have up there. So it kind of helps quickly like scan through and make sure that it's actually something that might be worth you reading. So I'm going to do a couple of quick polls. Everybody here familiar with Slido? I'm going to make you do Slido. So if you have your phone handy, pull out your phone. We're going to do a quick poll just to kind of so I can get a sense of who's here. It really helps me out in terms of trying to answer some questions. Then I'm going to hand it over to Stephen to do the LEEP Net Zero Energy Wall that is an old slide. The Larsen Truss case study presentation. So we're going to do that this morning. And then I'm going to hand it to hopefully Stephanie Geibelhaus is going to be here to do the CEIP presentation. Oh, I haven't seen her yet this morning. So we're going to hope she arrives. And we'll talk a little bit about the Airdrie CEIP program and how it relates to contractors. And then we'll have a chance to start looking at the wall library. And we'll have we'll have a break in there as well as some Q&A in there too. Okay, so if you have your phone handy, pull it out, scan the QR code. There is apparently free TELUS Wi-Fi in here, but there is a bit of a log-on step for it. I didn't try it myself. It was different than what I had expected. Do we have people join remotely too?
I have a couple.
Yeah, if you're online, you can do this too. Please, if you're in your online group, please also sign up. Okay, I'm going to advance to our first one. So, always curious to know who's at our session. So, how would you describe your work in as few words as possible? Somebody's laughing because I said describe your work. Not the quality of your work. I see what you actually do or what your boss thinks you do. Builder, renovator, energy advisor, good. These are the people I like to see.
Building envelope engineer, energy modeler. Behind the scenes.
All right, someone's gonna have to explain what behind the scenes means.
So yeah.
Oh, like you could have
Accounting.
said accountant. You would have known that was important. Okay. I like that somebody actually used the word retrofitter, like really dialed in on what we're doing here. We should normalize that.
Professional.
We'll let a couple more people chime in here. We just got like a couple. Okay, so lots of builders, lots of energy advisors. That's fantastic. That's really great. Okay, one word that describes your attitude towards deep energy retrofits. I realize I'm probably speaking to the choir, but I like no one said I couldn't have a friendly audience. Okay, good. I'd like to see that. Ooh, long-term value, there's a good one. That's a tough one, eh? That's a tough one to talk about sometimes. Okay, that's fantastic. Scale of 1 to 10, rate your level of understanding of a Larsen Truss. 10 being that you're taking over the case study presentation. Stephanie's gonna step aside. Stephen disagrees. Okay, pretty good. Oh, we have a couple people chiming in here at 10, so that's good. Well, that is good because we have several people who were involved in the case studies here today, so that's probably actually a good thing. So how ready are you today to build, inspect, insulate, work on a Larsen Truss? So if the other one was your level of knowledge, this one is your capability to actually take it on today. Okay, pretty similar mix there. Awesome. Okay, so that is the end of this, my Slido, or I have a little joining slide.
What?
Like, have an intro slide. Oh, there we go.
I'm just messing you up this morning.
I don't know. I think I messed myself up this morning. So we're really fortunate this morning to have joining us Stephen Magneron from Home Soul Construction. So Stephen has worked on 2 case studies that he's going to be presenting today. He's a senior building scientist with Home Soul, and he's going to be giving us a really excellent presentation about 2 case studies, one that was built here in Calgary, but one in Quebec, and taking a deep dive into the impacts of a Larsen Truss retrofit on these 2 examples. We will, oh, I know why I had that slide up now. So we will be using the Slido. So if you have the Slido open, the Q&A is now going to be open. So you're going to be able to post questions to the Q&A, and then we're going to be able to ask those to Stephen at the end here. And if that doesn't work, then we'll walk around and we'll ask a few questions. All right, so with that, Stephen, I'll hand it over to you, sir.
All right, wonderful. Thanks so much, Joe. I will try to share my appropriate screen here. Do you see my slide deck now, my opening page?
Maybe we'll have a thought here.
Yeah, give us half a second. I think we just have to.
Please stop sharing.
Get those at the top there.
There we go.
Yes, now we can see your slides, Stephen.
Okay, wonderful, excellent. Well, thanks so much for the intro. It's wonderful to be here. There's a pretty good crowd there and a good diversity of people there. I love the poll questions that were asked. So wonderful, wonderful group of people here. I also want to extend my thanks to the LEEP team for having me do this Larsen Truss case study. It's something that's been on my mind for a long time, and so we were blessed with a couple of projects that we could highlight this method of construction, whether it's new construction or renovation, both applicable. And also thanks for ENBIX, to ENBIX for having me out for this event and to help promote the study. So my name is Stephen Magneron. I'm a Master Energy Advisor at Home Soul Building Solutions. I'm the Ontario Manager, Home Souls throughout Canada, but I'm in the Ottawa area. And I've been very involved in the net zero and EA community since I've been with Home Soul since 2010. So lots of work over the years, anything from EnerGuide, existing buildings, new construction, Energy Star, R2000, Net Zero, and we've been fortunate enough to be involved in a few passive house projects. So happy to share my experience with Larsen Trusses in applying them to those kinds of programs. I'd also like to take a few moments to acknowledge the teams who have contributed to the 2 case studies. Felipe Fala from Retrofit Construction is the renovator for the case study number 1 in Quebec. Steve Norris, who I believe is in the crowd, is from Snap Building, and he's the renovator for the Calgary project. Jared Green from Jared Green Architect helped design, provide the designs for the Quebec project. Chelsea Thomas from Sol Invictus Energy Services was the Net Zero EA for the Calgary project, and Kim Walton from Bow Crow Design was the IDP facilitator for that project. So a big shout out to the key members of the team, so to speak, because it requires that team effort. In fact, I really like this slide saying that it takes a collaboration and an integrated design process, or IDP, to deliver an affordable, efficient, sustainable, resilient, and healthy high-performance building. So it's the idea that it takes a team to get to the goal, and the team needs to be together right from the start so that the analysis can be done, the performance goals and the budget can be met in a way that is as efficient as possible and cost optimized as well. So IDP, if you're not familiar with integrated design process, start looking into it and start getting your team together, because this is what sets a project up for success. So the agenda, as far as what I'll be presenting today, is a brief history of the Larsen Truss, where it started and how it's evolved to be implemented in case study number 1, which is the retrofit construction one in Quebec, and then case study number 2, which is Snap Building project in Alberta. And then we'll go over a couple of lessons learned and then the Q&A. So what got all this started? Well, the LEEP wall, the LEEP team developed the 4 walls in their Net Zero Energy Wall Guide series, which a lucky participant in person will get a hard copy of, which is amazing. And the 4 walls are these. So there's the wall number 1 is a split wall with vapor permeable exterior insulation. Then there's the split wall with wood fiber exterior insulation, which is fantastic because now we're starting to look at that embodied carbon content side of things as well, and a relatively new player in the insulation field. Then we've got a split wall with low permeance exterior insulation, low permeance meaning low drying potential to the outside. So typically some sort of foam product. And then we've got a double stud wall with an interior surface wall to round out the 4 walls. So this particular case study is an opportunity to present a 5th option, perhaps, that will address the need for wall design and construction that addresses, and this is in the case studies, it addresses the increased effective R value, with continuous insulation and reduced thermal bridging, a continuous air barrier, improved thermal performance, reduced heating and cooling loads, reduced risk of condensation within walls. So these are all the needs that have been highlighted to reduce risks. Water protection systems, reducing the risk of bulk water intrusion from rain, snow, wind. So not necessarily an energy criteria, but certainly a risk mitigation one. We want to keep the water away. And then also an effective vapor barrier or vapor retarder to reduce the risk of trapping moisture within the wall assembly, because that's we're talking a lot about moisture, and now if we are going to more insulated assembly details, we want that assurance that perhaps double vapor barriers are not created and that there is drying potential. So coming up with details that will limit that risk is what the wall guides are all about. So the Larsen Truss is one option that will be discussed in this particular case study. So the original Larsen Truss was developed by John Larsen in Edmonton, Alberta. It was in the 80s, and he developed it as a way to combat the increased labor or the technical side of things with respect to double stud wall. I believe the story that he told Martin Holliday from Green Building Advisor when he was interviewed by him was that there was a project in Jasper, and he had to, the framers were struggling in this remote area to do the double stud wall. And so he came up with this method of getting the framers to essentially build the house like they normally would, so nice and simple. And then he would come in as a subtrade to then add the poly as the vapor barrier and air barrier, and then add insulation using this method of ripping down a 2x4 to create basically 2x2s, and then creating this outrigger or ladder on the exterior of the wall to then add insulation, and then sheathing, and then siding. So it was a very effective way of creating a great air barrier and also adding a meaningful amount of insulation to the outside. And you can see the image there. That's from a Fine Home Building magazine issue where it discusses the original Larsen Truss. Since then, Fine Home Building, Green Home Building Advisors, a lot of publications have covered the Larsen Truss. Here's another one from 2009, where they the key points in this is that an effective R value of 40 can be achieved, which is, if you are familiar with Dr. Joe Stibrick's from Building Science Corporation's perfect wall and typical R values, R40 is appropriate for most climates, and certainly in a cold climate. So achieving that with the Larsen Truss is easy, both in new construction and for retrofits. The beauty with this is that the air barrier is protected when it's in the middle of the wall. Another check. The interior walls in a retrofit can remain untouched, and we'll see that in one of the case studies. There could be high labor costs, but that is something that needs to be weighed with any sort of strategy. And there could be increases in the gross building area lot line. So that's something that would need to be worked out based on the municipality that the project is located in. So this was a great strategy, and this particular article was 6 proven ways to build energy efficient smart walls. So the Larsen Truss got featured in that. In 2013, the Cold Climate Housing Research in Alaska also conducted studies on the use of Larsen trusses for both new construction and renovations. And this research paper confirmed that superinsulated vapor permeable or vapor open wall design is appropriate for a cold climate. The key attributes that they found in this was that the great air tightness of this particular project that was studied made it easier to achieve the primary air barrier when the air barrier was located in the middle of the assembly, where it's protected from both the elements and the occupants. And then now the load-bearing structural wall is essentially a service cavity with no vapor retarder on the inside or special consideration with respect to air tightness. So it made it easier for the subtrades involved in that side of things to not have to think about the air tightness unless something actually does go through that primary air barrier layer. They also determined that a class 1 vapor retarder is not necessary in an assembly detail like this, because the vapor permeability provides greater drying potential for the wall throughout the year, because there's drying potential on both sides. So super, super interesting. The use of cellulose in this particular study also, because of also made the wall safer, because the cellulose is able to store moisture and buffer it, so that if moisture gets in, it is able to redistribute. And because there's great drying potential, there's no risk of moisture damage or a big accumulation of moisture or the development of mold. So lots of checks in the right direction as far as this being an appropriate wall assembly for cold climates. Interestingly, the NRCan Keeping the Heat In publication, which was first released in 2004 and is currently available online. Actually, these screenshots are from the online version. In the section 7, insulating walls, insulating, renovating, and building additions. So this is more for homeowners or renovators who are wanting to improve the buildings and add insulation and make the homes more airtight. We see that a Larsen Truss is highlighted as a alternative method of doing this deep energy retrofit. It's a technique not only for renovators, but also DIYers. And it has, in the publication, it also has really great points to think of, like adding significant amounts of insulation. The insulation only ends up being about 15 to 20% of the total cost. The rest is additional materials and labor. You have to think about details like window door bucks and other penetrations for services. Extend past the walls to cover the headers. So instead of just attaching to the walls itself, you actually extend above and below so that you cover those headers, which are sticking points for air tightness and adding a good amount of insulation in most cases. And the ability to install a new air barrier. They even have another detail that is sort of like a modified Larsen Truss, where a box beam is used at the base, and then a 2x4 wall is built on top of that to allow for insulation to be added, whether it's batt insulation, as you can see in that image, or blown in cellulose or some other sort of insulation. So lots of great examples of the Larsen Truss or a modified Larsen Truss method. Speaking of modified Larsen Truss, Fine Home Building came up with a more recent article of understanding Larsen Trusses and the different styles of methods of essentially doing a Larsen Truss, but in a different way. So that's what we're calling the modified Larsen Truss. And here's one of them, a very popular one that was used using I-joists to simplify the construction of the Larsen Truss by leveraging a product that can achieve the same goal by adding a thick layer of insulation to the exterior of the building. The I-joists come in certain depths to make it easier. So whether it's a 9-inch, 12-inch, 14, 16-inch, whatever your depth needs, it comes already pre-cut, pre-assembled, basically. So it's leveraging that idea. And those in the passive house world have already done thermal analysis to suggest that the web, the OSB web of an I-joist, doesn't represent much of a thermal bridge at all. It's not like a wood stud that goes all the way through, that's 1.5 inches wide and right through. The minimal amount of thermal bridging that comes from that OSB doesn't really factor into it. So we can almost say that the Larsen Truss is a continuous amount of insulation. Then we have an open web floor style truss or a wall truss. Now this is typically manufactured, and it could be load bearing. That takes it steps away from that sort of Larsen Truss, where the Larsen Truss is not load bearing, and now we're calling it a wall truss. But it could get hung on the outside as a method to create a modified Larsen Truss. A good option to also have a really sturdy version of it that is pre-manufactured and then brought out on site. And then we have, in this particular article, they call it the Swinburne solution. And it's an example of a site-built option that essentially represents any other method with which to achieve the same Larsen Truss characteristics. And it can differ greatly depending on the specifics of the project. But I want you to remember that the Larsen Truss is only one part of the deep energy retrofit. It's dealing with the above grade walls and headers. And one must also consider all of the other components in the to the thermal enclosure with respect to a deep energy retrofit. So the below grade walls and slab, the roof, windows, air barrier, ventilation, all that needs to be taken care of. And I really like this image from River Architects. They hand drew this to show the cross section of their retrofit, pointing out the Larsen Truss. And as you see, it's only one part of the big picture of that particular project in Cold Spring, New York, which is now their office, actually. So that's a quick history on the Larsen Truss and how we've moved from the 80s to now with different methods of achieving essentially the same goal. And so we start with the first case study. This is a project in Saint-Agathe in Quebec, near Montreal. It started its life as a barn. We aren't sure when it was originally built, but the walls above grade used a construction method called pièce sur pièce, which is post and plank, and it was very common in Quebec in the late 18th century and early up till the early 20th century. This method of construction usually included a 6x6 square post that was usually spaced around 4 to 6 feet apart with 3-inch thick pine or spruce boards as the sheathing. So very heavy duty, used a lot of the local lumber and was very, very popular. Even in Montreal, we, with Felipe at Retrofit Construction, had a project where this method of construction was found in his own project there as well. Riverstone was assumed to have once clad this building, and well, based on the extension of the rubble foundation of about 8 inches. The barn was converted in the 60s, around 1968, we reckon, with siding rather than stone. So who knows what happened there? Perhaps the stone was repurposed or had deteriorated, and so siding was installed, as you can see in that particular picture of the pre-retrofit house. And also interior insulation was added with the 2x6 wall. This house, which was chosen specifically by the homeowner and Felipe, because they wanted to do a net zero retrofit. The building was in the right location, which is always important, but it had a really simple shape, a great orientation. The front of the house there that you can see slightly shaded with the low sun is facing south, so a great orientation. And it so simple shape, good orientation. It had deferred maintenance, meaning that there was a lot of things that needed upgrading for the whole house, which is always a good thumbs up, because if you have to upgrade it, now's an opportunity to add some DER methods to it. So if it's the whole house, then you have a more holistic approach available to you. And so all these things contributed to purchasing this particular house. A chainsaw retrofit was part of the plan from the beginning, and I'll describe that in a moment if you're not aware of it. But it allowed the shape to be maintained and just a few of the windows to be resized, a door to be moved, and then an exterior 3-season porch to be added on the west side of the house. So a perfect opportunity to set the project up for success. Here are the pre and post retrofit reports that were provided as part of the CHBA Net Zero Home Labeling Program. The rating of the house was originally 179 gigajoules per year, and the post retrofit results reduced that down to 46 gigajoules per year. The typical new house that you can see there was originally at 89 gigajoules per year. So that's the house with the reference house, which, or a typical new house, the current code characteristics applied to it, whether it's insulation, window, air tightness, all those things. So it's 89 gigajoules per year. And you can see that there's a slight difference in the typical new house between the pre and post retrofit. And that's really because of the chainsaw retrofit approach, where the volume got a little bit bigger and slightly increased surface area, because now the attics are now conditioned space with the chainsaw retrofit happening. And so the increased volume and surface area increased the energy consumption of the typical new house. So chainsaw retrofit, just to describe that, actually, I think I'll be describing that in the next slide, so I'll hold on to that and keep you waiting with that description if you're not aware of it. With respect to the end use energy, so when you get an EnerGuide rating label, then it tells you the breakdown of where the energy is being used with these major appliances or usage. So space heating, space cooling, water heating, ventilation, lights and appliances, and other electrical. And you can see in this particular case that space heating was 75% of the energy consumption pre-retrofit. And then when we go to the post-retrofit, that's significantly reduced down to 18%. And well, what does that mean? Well, it's a percentage of the total. So 75% of the 179 gigajoules per year went to space heating. Space cooling was added. So now you see in the pre-retrofit, there was no space cooling. And now in the post-retrofit, you have 10% of energy used for space cooling, whether the homeowner actually uses it or not, because the cold climate air source heat pump was introduced, and it does both heating and cooling. Now we have an additional load that needs to be accounted for. And you can see another big mover with respect to end use energy is the hot water heating, which went from an electric resistance tank to a split heat pump water heater. So lots of efficiencies there. When we look at the heat loss, another output of the EnerGuide rating system is an identification of, okay, well, of my thermal enclosure, where is the heat being lost during the winter? And it's broken up based on the location. So you can see here that air leakage is the highest amount of heat loss in the pre-retrofit. And then in the post-retrofit, it ends up being one of the smaller parts of it. And we'll be discussing that as throughout this course, the course of this presentation. But the reductions in, well, the ratios of heat loss between the pre and post are relatively the same, with the exception of that air tightness, because everything was done to this house. The walls, the roof, the basement walls, the air tightness, everything was increased with respect to insulation. So the relative ratio dropped at about the same rate. So here are some results, some key metrics from the outputs. We've got the pre-retrofit effective R value of the walls. We've got the total EnerGuide rating in gigajoules per year. And if you're not familiar with that rating, so a gigajoule is a unit of energy that is convertible from either kilowatt hours for electricity or cubic meters of natural gas or liters of propane. That can all get converted into a gigajoule, which is what is represented in the EnerGuide rating system. The wall heat loss, so the amount of heat loss that goes through the wall specifically over a heating season. In this particular case, pre-retrofit, it's about 17.5 gigajoules. We've got an air tightness. So the pre-retrofit air tightness was 8.93 ACH. If you're not familiar with ACH, it's air changes per hour. So it's a volumetric air tightness value that has an impact on the energy model. So at 50 pascals, which is when we do the blower door test, it's equivalent of a 50k an hour wind, 50k an hour wind on all sides of the building. And while it's at that pressure, the house at pre-retrofit would, the entire volume of the house would exchange almost 9 times. So you can imagine One, how much of an energy penalty that is if you have a really leaky house like that was, and also the potential discomfort and the building durability issue that could come from that. The next value here is the ELA. That's the equivalent leakage area. And I've got it in inches squared and in metric as well, in centimeters squared. And this is the theoretical hole if you were to combine all of the air leaks into one. So we have a 285 square inch hole in the house. More on that later. The NLR is another air tightness metric. So we've got ACH, now we've got NLR. NLR is the CFM per square foot of the thermal enclosure, or the metric version is liters per second per meter squared. And 0.64 is pretty high at that point. Then we have the whole house F280 heat loss. So using an approved whole house F280 calculator called Volta Snap, we came up with the value of almost 72,000 BTUs for the whole house, of which the headers and the walls contributed to about 4,300 BTUs. So when we go to the post retrofit, now we see the improvements that have happened. We have increased the effective R value of the wall from R20 to almost R50. We're at R47-ish, which is a difference of 133%. Amazing. Then we've got reductions, reducing the total ERS gigajoule per year down to 46. The wall heat loss gets reduced by 73%. The ACH, amazing result, 8.93 down to 0.74 at final. Huge improvements there. The ELA drops by 93% as well as the NLR. So huge reductions there. When we look at the whole house F280, we've gone from 72,000 BTUs to below 15,000 BTUs. And that heat loss is what we use to size the heating system. So instead of having a huge furnace, now we can really get by with a very minimally sized cold climate air source heat pump. So amazing reductions there. And of that, the contribution to the F280 heat loss is also reduced significantly with respect to the headers and walls only. So that's a nice little snapshot summary of all the details and results from that. So here is a great little cross section of the chainsaw retrofit, which I can explain a little bit now. Essentially, a chainsaw retrofit removes the roof's overhang with or without a chainsaw, although a chainsaw retrofit, in my opinion, has a nice ring to it. The building is then wrapped with an airtight membrane, tested for air tightness, and then insulation is added to the exterior of the walls and the roof. The overhangs are reframed because we do want good overhangs for moisture deflection. New siding and roofing gets installed, and that's it. That's essentially the chainsaw retrofit. If windows are to be reused, then it might be a good idea to uninstall the windows and then reinstall them and make sure that there's good flashing details at that time, so that we don't compromise the new Larsen Truss that is installed on the exterior, and we take the opportunity to make sure that the project will not be at risk of any moisture that gets into the wall system at all through windows that will eventually likely leak. So it's a very effective way to achieve great air tightness and add a meaningful amount of insulation to the thermal enclosure. And so it's a great opportunity to use the Larsen Truss approach, although it's not the only approach that can be taken. The cross-section provides a really great, clear red line for the air barrier strategy, which is super important. Now, this structure, as we mentioned before, was simple in shape, but that red line approach of identifying the path of the continuous air barrier is an important step in the process, especially if there are tricky details, which we don't see here, but if a typical project that might have a room above a garage, for example, then having a detail there to connect that red line all the way through and identify the products and processes and strategies for creating that path of continuity is a really important strategy and exercise to go through for every project. So I really like that this image has done that. The detail of the wall to roof is highlighted in this image, where it shows that continuity of the air barrier. And in this particular iteration of the details, we're showing almost like a true original Larsen Truss, but in practice that was removed. Those plywood gussets were removed because it was deemed unnecessary. And well, this was actually more like a modified Swinburne Larsen Truss, because it's not continuous with respect to they use blocking instead of a continuous ripped 2x4. So a slight modification to the original Larsen Truss from that perspective. And you can see also the over roofing, so using I-joists for the roof to add a little bit more structure. Although there was some restructuring of the original 2x6s, the original rafters, but the over roofing also provided a little bit more structure that could take the additional weight of the future solar panels. Here is a detail of the wall to foundation that shows the depth of the foundation, the original foundation that originally carried the riverstone cladding, but now bears the modified Larsen Truss. The top of the foundation needed some repairs, which made it the perfect substrate for the exterior 2x4 of the modified Larsen Truss. So instead of having these gussets cantilever out, there was no need for the cantilever, because that 2x4 just was held in place because of the foundation. We came up, because of that, we developed the strategy of an 8-inch Larsen Truss. So there's a nice amount of continuous insulation, and then the exterior 2x4. So great way of optimizing the solution based on the variations of the particular project. Here's a great image that shows that 3-inch solid wood planks of the pièce-sur-pièce, or the post and plank wall, and then the forming repair that needed to be done at the top of the original rubble foundation, as well as the development of the plywood bucks framed for the window. The plywood bucks were originally installed deeper than 8 inches in case of some modifications afterwards with respect to the Larsen Truss. And then once the wall was installed, the bucks were trimmed to the right depth, and that made it a simpler situation for this particular project. It allowed for the primary air barrier to be installed to the window bucks, and the interior of the window bucks to be also properly flashed and addressed from a water and air tightness perspective. However, when we did our mid-construction air tightness test, because of that extension of the window bucks, we did see that there was a little bit of air leakage that was happening in the corners because the plywood bucks continued out and weren't trimmed out. There was actually some discontinuity there, which was minimal in the grand scheme of things. Here is the primary air barrier once it was completed, and the only thing missing is a red ribbon on top, because you can see how neat and tidy. It's almost like a wrapped Christmas present, and in this case the windows and doors were also installed at that time, so scheduling was super important to make sure that windows and doors were available early in the construction process, so that an early mid-construction air tightness test could be done as soon as the primary air barrier was complete. So look how clean the wall to roof corner junction is when a chainsaw retrofit approach is taken. That, if you can imagine, if you were doing it all from the inside, would be a really tricky area to approach. But with an exterior approach like this, chainsaw retrofit with Larsen Truss, that detail is really simplified. and made much easier to achieve. As far as penetrations that go through the primary air barrier, the one hole for one penetration that methodology is used, which really simplifies the process because the penetration is accessible from the outside. We don't have to work above our heads in header spaces that are tight and perhaps cramped and not very easy to access all the way around. With the exterior approach, it really makes it easy to get a nice seal in those locations. Even for hose bibs, roughing them in so that they achieve the appropriate depth and then are sealed appropriately makes it for a great air seal. So we don't have a red ribbon, but we do have the red door of truth, or also known as the blower door. So remember, the pre-retrofit air tightness result was 8.93 ACH with an ELA of 285 square inches and 0.64 CFM. At the first mid-construction test, we achieved 0.73 ACH, which was an amazing result. So this is mid-construction, first time out, knocked it out of the park. What does this mean for the F280, whole house F280? It's about a 92% reduction. When you look at the air leakage component of the F280 calculation, it was at about 34,000 BTUs. And with a result like this, now we're down to 22,000 BTUs associated with air leakage. So that's a 2.5 ton reduction when we're looking at it from an air source heat pump sizing side of things, which is huge. All that to say, setting up a project up for a great air tightness is really important, and this goes to show that that's a great strategy to help achieve that. We also attempted to do a pressurization test just to see, for those of you who are aware of passive house, they do the air tightness in both directions, both depressurization, so we're sucking the air out of the house, but also pressurizing it to see what the results are there. But the test was quickly aborted when we realized that the primary air barrier on the roof wasn't secured enough, and it was starting to balloon up, and we had some staples popping. So we aborted that and saved it for the next time. And we did do a second mid-construction test once the Larsen Truss was installed, and the redundant secondary exterior air barrier, WRB, was also installed. And those familiar with blower door testing might recognize that the D-ring is being used in this Minneapolis Model 3 fan, which means it's really tight. So that's the smaller the hole of the fan that's being used to do the air tightness test, the tighter it is. So here are the results of the second mid-construction test, and we improved both and were able to do both a depressurization and pressurization test. And interestingly, the pressurization test in this case was much better, and the average was 0.47 ACH. But I'll point you to the ELA, which reduced from even the 20 inches squared in the previous test down to 14.5 for the average of these two tests. But what does that mean? So that's essentially like the pre-retrofit hole was the size of a 19-inch diameter pizza, whereas the post-retrofit, or at this particular stage, was the equivalent of a CD or DVD, for those of you who remember what those are. So a significant reduction in the hole. Here's the construction of that this modified Larsen Truss. The beauty of it is that there is that continuous insulation of cellulose in this particular case, and then the wall on the outside of that. Here it goes up the gable end wall, and the gussets of a typical Larsen Truss probably isn't fully required because it's such a small amount of wall area on the grand scheme of things, and the window bucks are essentially keeping that wall from wind effects and keeping it spaced appropriately from the existing wall. On the interior side, the original 2x6s were not meant to be touched. However, in the process of resizing all the windows and moving the doors, there were too many areas of damage, and finally the decision was made to update all of the interior wall structure and re-insulate with R22 mineral wool, vapor variable smart membrane on the interior, which also served as a redundant air barrier. Perhaps a little unnecessary on the grand scheme of things. So considering that the mid-construction air tightness test was so amazing, and in hindsight, installing the Intello perhaps on the exterior as the primary air barrier may have provided the appropriate air control and vapor control, and could have allowed the interior membrane and strapping that you see in this image to be omitted to save costs. So that's one of those learning opportunities for this particular project. It's also possible that it may have been more cost effective perhaps to make the Larsen Truss deeper and actually have it cantilever out to achieve the same effective R value than it would have been to do anything to the interior other than a little bit of restructuring and stuff like that. So insulation may not have been required, the air tightness membrane may not have been required, and that could have perhaps saved cost if that analysis had been done. So one of those the issues with retrofits is that you have to make decisions on the fly in certain circumstances when problems arise, and that analysis is a difficult one to do every single time. So food for thought for the next project. Speaking of costs, Felipe did provide a rough breakdown on the costs associated with the Larsen Truss, and also the comparisons with other insulation or methods for the exterior insulation only in this particular analysis. So this analysis does not include the interior wall with the R22 and Intello and strapping. It does include the window bucks and the brick ledge repointing and capping, because these two are essentially a constant for all four options of the analysis for the exterior component of this retrofit. Where they differed was the exterior insulation framing, and if applicable, the labor associated with it. Then I also divided the costs by the total wall area and header area for a cost per square foot. The first option was 8 inches of mineral wool. This is not associated with the Larsen Truss, so instead it's 8 inches of semi-rigid mineral wool that was attached with long screws and strapping. At the time of this cost exercise, this product was prohibitively expensive compared to the other options. It may have also been discussed that the estimate for the labor may have been on the conservative side, because while the product is rather dense, it's still only semi-rigid. So ensuring that the strapping for the siding is straight and true can be time consuming. It requires a string line to be used and the strapping to be backed in or out to be perfect in line. The nice thing about the 3-inch solid wood plank is that the installer wouldn't have to be so precise with their screw alignment to find a stud, because they could basically go in anywhere. So it's a good option for this R32-ish on the exterior. Actually, the first time I've seen this in comparison with the next option, which is the I-joist, the project team, it was a passive house in Victoria, where there were 2 side-by-side projects that were exactly the same, but they used one method with 8 inches of mineral wool, just like we see here, and the other one with the I-joist. And they preferred the I-joist because of that buildability of something straight and true that was easy to install and didn't have that labor associated with it as far as the screws were considered. So the next option that Felipe analyzed was the I-joist. And in this particular case, it seemed that the I-joist themselves were an expensive component, which made this a bit more cost prohibitive. Then there's the Larsen Truss, or perhaps we'll call it the Swinburne Larsen Truss option, that was more affordable. Cellulose in this case is a very affordable product, and the estimate for the materials and labor to install the blocks and gussets and exterior 2x4s combined to be lower than the I-joist option that also used cellulose. And finally, considering that the brick ledge repointing and capping was required, and it was the perfect depth, it made the most sense to eliminate the blocks and gussets and just build the exterior 2x4 resting on that, that foundation wall. It would have been interesting to have included the interior wall costs, as I mentioned before, with the 2x6 insulation, Intello and strapping. That would have been a constant with these options. Then created a fifth option that reduced the interior wall to a 2x4, eliminated the insulation in Intello and strapping, but increased the depth of the modified Larsen Truss to a depth that would achieve the same effective R value, and see if what the cost difference would have been in that situation. So perhaps for the next project, Felipe. As far as scheduling goes, this is the brief outline of what Felipe provided. So there was wall demolition that took a week, resizing the windows and window bucks, restructuring the walls where they were damaged. That took a couple of weeks. Repairing the cap, that stone foundation, took about a week. Window installation, about a week. Roof, now we're adding in a little bit of that chainsaw retrofit component to it. So the roof work and everything that was surrounding that took about 3 weeks. Interior wall and roof insulation and primary air barrier also took a week. Adding the Larsen trusses took a week. Recreating the roof overhangs and that framing structure took another week. And the final air tightness and dense pack cellulose another week. And then the rain screen, kick-out flashing and siding installation about 3 weeks. So 15 weeks in total for this entire process of the chainsaw retrofit. So no, not just looking at the walls, but the entire thermal enclosure. We did a carbon analysis on this using the material carbon emissions estimator, or MCE squared, from NRCan to analyze the including the interior walls, so the wall only in this particular case. The first option there you see as built, so we've got the mineral wool bats on the interior with the cellulose on the outside within the modified Larsen Truss. So this analysis was really just looking at the installation material, just to hyper focus on that part of the construction. The second option that you see here is if we use the mineral wool, both on the interior and on the exterior. And you can see that it's, while mineral wool is an excellent product, thermally and for all its moisture, hydric, not hydric buffering, but hydrophobic characteristics, or it drains, it is fairly high in embodied carbon, as we can see in this analysis. The third option is if we were to use 100% spray foam using the new HFO blowing agent that is relatively low in global warming potential, but as you can see here, it still has a high upfront cost with respect to carbon. And then the fourth one here is when we exchange the interior mineral bats for cellulose instead. Or perhaps if we were to look at that fifth cost option of all of the insulation to the outside, it'd be about the same. So now we're really carbon sequestering. So we're in the negative, which is a positive from an upfront carbon calculation. So when it's negative, it means it's sequestering carbon, and that offsets other higher carbon attributes of a particular project. So in this, it goes to show that the insulation material choice plays a big factor. And I'll mention that for all of these, we kept the R values the same. So there might have been less thickness of insulation when spray foam is used, which is something that a project would need to consider as well, as far as how deep they can go or how far they can extend. And so this is part of that calculation. Then we also looked at the operational and energy carbon. And because this project is located in Quebec, the greenhouse gas emissions associated with this all-electric project pre-retrofit is very minimal on the grand scheme of things. And then while energy reduction is significantly reduced, greenhouse gas emissions, relatively speaking, is also significantly reduced, but very minimal reduction on the grand scheme of things. So case study number 2 is in Alberta. This project is in Calgary, about 30-45 minutes south of the event's location. The project team included C, Chelsea, and Kim, who worked with the homeowner to help them achieve their goals of reducing greenhouse gas emissions. The focus was on correcting comfort issues, especially regarding the windows, insulation, and air tightness. And through the integrated design process, a roadmap was developed and a phased retrofit was set in place. So the post-retrofit evaluation that is part of this presentation is but a stepping stone to the final plan. So keep that in mind when you look at the results that we present here. And we are mostly focusing on that Larsen Truss aspect of it. So here it is in the completion of the phase 1, let's call it, of the retrofit that was completed last year. With respect to the results, here are the reductions pre-retrofit compared to post-retrofit, 119 gigajoules down to 68 gigajoules. And just to explain that a little bit more, the upgrades that were included in this phase 1 was the Larsen Truss. So above grade walls, the crawl space had some insulation added to it and some air tightness details. The windows were upgraded with nice triple glazed windows with low U value, low SHGC from Innotech windows. The air tightness was also reduced. We'll go into that a little bit more. Ventilation was added, domestic hot water, so a heat pump water heater was introduced, but the existing gas furnace was remained and a heat pump wasn't added to it. If it was, then and a better air tightness, so in phase 2, assuming that a cold climate air source heat pump would be installed, adding insulation and air tightness would be achieved as well. There's the potential that 68 gigajoules per year could be reduced down to about 52. The biggest challenge, the biggest change in energy consumption here, when we look at the end use energy, is the water heating. Thanks to that hybrid heat pump water heater, you can see that it drops from 22% of the end use energy all the way down to 5%. Interestingly, the space heating seems to go up, but it's going up relatively to everything else. And because while there's a lot of improvement to reducing the heat loss, the actual heating system wasn't upgraded. And so the improvement of the domestic hot water made the relative actual energy consumption of the space heating seemingly go up. It's a bit of a conundrum there. A bit of a weird one that as far as the results go. Here are the heat loss analysis and the ratio of where the heat was being lost. And you can see that the Larsen Truss made in the main walls, made a significant drop down, but there are other areas that also contributed to that. Here are the results summary. So I won't go into detail about all the specifics in the headings, but we see that these results going from an effective 8, R value of 8, and then the post-retrofit actually increases it to an effective R38. The ERS drops from 119 to 68. The operational greenhouse gas emissions goes from 10.8 to 8.1. The amount of heat loss through the walls is significantly reduced, and the ACH is also cut basically in half, as well as the ELA and the NLR. And When we look at the whole house F280 calculation, it goes from about 46,000 BTUs down to 25,000 BTUs, which is a significant reduction in the size of the heating system that's required. And of that, the headers and walls only contribution goes from about 11,000 BTUs down to 3,000 BTUs. And so here you see the differences, but I noticed that other than the first one, which is an increase, all the others should be a negative sign. So 43% reduction in the total gigajoules per year, and then all the others other reduction associated with that. So because to compare against the case study number one, where case study number one was a holistic everything done one and done, this is a phased approach, and so in phase one we still achieved significant energy reductions or reductions in all of these values. So a huge win on that part. Here's a great cross-section of the details that were part of this retrofit at the top. And I think I can zoom in perhaps for those, if we can see that. So at the top, you can see that the spray foam is added to the top of the wall, top of the Larsen Truss, and also to the underside of the sheathing to create an air tightness continuity from the wall, and then the future work that gets done to the attic. And because it's cutting out that airflow into the attic, a roof vent is installed to provide the ventilation that's required in the attic space. It looks like I can't zoom in and have the laser pointer at the same time, so I'll just go like this. The connection detail of the Larsen Truss with the top plate attached to the existing truss overhang simplifies the process and allows for the modification of the original Larsen Truss detail. And you'll notice that the 2-foot overhang has now been reduced to about 1'2", according to this detail. It also shows the installation of the windows at the exterior edge of the existing 2x4 walls to get that into that middle third of the wall sweet spot to maximize the thermal efficiency of the wall placement, but not needing any additional structural requirements to bear that window. So we're using the original load-bearing wall to do that. If it was out a little bit further, then there may be more structural requirements to hold the bigger windows up at least. I really also like the aggressively sloped sill that not only helps deflect bulk water away from the house for great moisture management, but the white flashing with that angle can also act as a bit of a light shelf to help reflect diffuse light further into the house, which is a nice little detail. At the bottom of the Larsen Truss, you can see that it's anchored to the existing wall with one long gusset and blocking, as opposed to gussets all the way up the wall, like the original Larsen Truss. And this is in combination with the top plate being attached to the existing roof truss. So now we don't have those additional gussets and the labor and material savings that come with that. Additional foam insulation was added to the foundation wall to provide additional thermal control, and also to maybe from an aesthetics perspective to reduce the cantilever of the Larsen Truss. Here's the original siding, wood siding that was carefully deconstructed for reuse. A really great thumbs up there for Steve and his team for thinking of that rather than demolishing. Deconstruction for reuse is a great environmental thumbs up. The existing plywood was exposed and it's inspected for damage. I didn't hear of any significant repairs that was required, so assuming that they were able to just carry on, but that's a great reason to get rid of the siding and so that the inspection can be done. The project was fortunate enough to have uniform deep overhangs all the way around. You can see in the gable end there that it's just as deep as it is at the wall, which is nice because oftentimes the gable end typically has a a small overhang, which if you're adding in an 8-inch Larsen Truss to it, and it's only a 6-inch overhang, now there's some re-roofing that would need to be done at the top. So that's a nice little add-on there, or nice little feature that they have with this particular project. The house wrap was added as the primary air barrier to the walls, and you can see here that the blocking has already started with that the gussets. Then the 2x4 wall is attached to the gussets and also to a top plate that's on the underside of the roof truss. And then insul web netting is used. It's an extra step in the process, but the insul web is an air permeable membrane for cellulose installation, and it allows the dense packing of the cellulose to be done with air that can move out, so it doesn't give that bowing effect of the air, of the membrane that's on the exterior. Unlike the previous project where there was some bowing and blocks needed to be put in behind the strapping to prevent that bowing, the use of the insul web allowed for the cellulose to be installed without any significant bowing and additional strapping that to keep that in check. So I thought that was a nice comparison between the two. Now it does need to have a weather-resistant barrier put on top of it, so it is an extra step. So it's certainly one of those pros and cons things that projects would need to weigh up. Here's another look at the sequence of the Larsen Truss installation, including a window. So we've got the siding and the felt paper removed, then the Tyvek primary air barrier is installed, in this case over the window rough opening, because one of the scheduling issues with this project was the windows didn't show up until later in the project, so they had to work around that. Then you can also see the spray foam installed at the top of the wall into that roof space, so blocking off the ventilation there, but then carrying on the air barrier strategy to the interior of the attic, and then down the wall on the inside in that particular case. The Larsen Truss is framed, the wall, the window buck is framed as well. Then the exterior house wrap is installed after the dense pack cellulose installation with that nice sloped and flashed sill. And then the exterior, then the windows are installed with the horizontal strapping and the windows. So a nice little sweet sequence there in one particular location of the house. You can see here that to promote great drainage, 1/4-inch plywood blocks were installed between the horizontal strapping and the exterior 2x4 of the Larsen trusses to separate the strapping from the siding. So flying battens weren't required, like case study number 1 needed, because of the air permeable insul web. And maybe I can zoom in here in case that, so we can get a better look. You can just see that there's the horizontal strapping is not tight up against the Tyvek, so any bulk moisture that does get in behind will have a drainage path to go down. So a nice little touch there, I thought, which was great. And then the siding goes on, which is a nice horizontal, well, vertical board and batten siding that is a hardy cement board. This project did a hydrothermal analysis. It was performed by Kim Walton from Bocro Design. She used a software called ENBIX. It's a European software where you can enter all the layers of the building component to calculate the U value, but you also get information about the level of heat loss, some moisture problem analysis, and ecological balance. the free version allows this condensation risk of an assembly, which is what we're highlighting in this particular analysis. So, which was done after the phase of the project, after the completion of this phase of the project, rather, to confirm the assumptions of the performance of the wall from a condensation risk perspective. So for the calculations, just to give you some boundary conditions of the amount of water condensation that might be present in this wall, the climate was set at an inside temperature of 21 degrees Celsius and relative humidity of 40%, and outside was minus 25 Celsius with 80% relative humidity. So this model is more of a static model, although it does say that it's over a 90-day period, but it's not as dynamic as a WFI hydrothermal analysis, if anyone's familiar with that sort of output. And you can see on the left, and I'll have to zoom in here just to explain this a little bit more. Let's see, or maybe I'll just use the laser pointer here. So on the left, you've got the relative humidity, and so this through the, so this is interior, this is exterior, and this line here is the relative humidity through the assembly itself. Now, all of these components you can see labeled as each layer of the assembly. And in this particular case, number 2 is the original poly, that is the vapor retarder and the original air barrier. And so that's there, which is why on the interior it drops down precipitously and then carries its way through to the exterior, where it starts to climb as it gets colder on the outside. Now, the way that you read this is that the saturation point, or at 100%, is this blue line at the top. And if this relative humidity line crosses the saturation point, that would suggest that condensation will occur and there's a potential risk there, which would then be shown in this particular image here, which we don't see because the lines do not cross and there are no water issues there. They also have this image here where it essentially says that there is no condensate and it is a dry assembly detail from a condensation risk and a mold formation perspective. So a great little tool that that is nice to use as part of this analysis. So I had Kim do some further investigation to see what the impact would be if, let's say, we put sheathing, an OSB or a plywood on the exterior to see if condensation might occur in that scenario. And sure enough, it does. Now, I did realize after we had done this that the boundary conditions had changed a little bit. The interior was still 21 degrees, the exterior and 40% relative humidity, but the outside was changed to a warmer minus 15 Celsius and 65% relative humidity. And at that level, there was condensation on the backside of the OSB. I believe it's OSB or the plywood it is. But it took 2 days to dry. So a caution, but there's drying potential, perhaps because it's plywood and there is drying potential with plywood. Now, if we had used minus 25 degrees, I'm going to guess that the drying days would probably increase. There might be more wetting that comes with it, but for all intents and purposes, it's a relatively safe detail. I don't know what they use for air tightness, but that's another big component to that. I also presented another hypothetical, and now this is in Ottawa, where we have hot, humid summers, just to take this away from Alberta and give it a Canadian perspective. So Ottawa, if we assume a 35 degrees Celsius on the exterior and relative humidity of 70%, with the same interior conditions, perhaps a little bit more humid, with the poly in this location and the interior being cooled, there's actually a wetting potential in the summertime, which is super interesting. It's not as huge as that solar-driven vapor drive that we see in foundation walls, but the risk is there nonetheless, and it's still, well, it says that there's a high potential for a longer period for it to dry. But this is a bit more of an extreme case where it's 21 degrees inside, which actually makes you wonder if the risk there is because it's a really low, we're focusing more on reducing or cooling the interior as opposed to making it drier. So with in the summertime, perhaps our focus should be on reducing that relative humidity, so dehumidifying rather than cooling. But that's just an aside that I thought was interesting and certainly requires a bit more evaluation in the future. From a cost perspective, here's the breakdown of this particular project. Comparison of other insulation strategies wasn't done for this project, but because of Steve's experience with other strategies, he wanted to try a Larsen Truss for this project right from the get-go, and these are the results. So interestingly, it's very, very similar to Felipe's results as far as costing goes. Certainly from a cost per square foot, it's only a couple of dollars, within a couple of dollars of each other, which is interesting because it's, you know, across the country there's not that much of a difference from a cost perspective. In both cases, they both suggested that perhaps the costs would go down with more experience of the same approach on subsequent projects. Perhaps in the third, fourth, fifth iteration, there would be some optimization of costs from that perspective. When we looked at the schedule of this, there's a bit less time, but in this particular case, we're not doing the chainsaw retrofit, so we're not including the roof. The timing included the abatement of some asbestos-containing stucco. That took a week. Deconstruction of that lap siding, that took a week. The primary air barrier, so that Tyvek, then the Larsen Truss window bucks, that took a couple of weeks. And then the installation of the cellulose exterior WRB, windows and strapping took another couple of weeks. And then the siding to finish things off took a couple of more weeks. So eight weeks in total for this, the Larsen Truss component of this retrofit. And we did the MCE squared, the upfront embodied carbon analysis as well, because the existing wall wasn't touched in this particular project, and it was all Larsen Truss, all exterior of the existing plywood. We just analyzed that component of this particular wall. So the same effective R value was achieved, and in the first option, it's the as-built Larsen Truss with dense back cellulose, which is really low, but now we see that it's on the positive side, which, as we mentioned, is bad from a carbon perspective, although it's super low. So when I say bad, it's not bad, but we are typically looking for a carbon sequestering or as low as possible. This does include the fiber cement siding, which has a high embodied carbon content, and that we didn't change that. So that's consistent with all of these options. So it's because of the fiber cement siding that the cellulose was not able to completely offset it, but it went a long way, I would say. The second option was, in this case, 7 inches of semi-rigid mineral wool that had a very similar embodied carbon impact as the next option, which is 7 inches of EPS, or expanded polystyrene. Then the next option is the 6 inches of XPS, which showed to be the highest of all of these, even using the next gen product that uses the lower global warming potential blowing agents. The one that is carbon sequestering is using rigid wood fiberboard. Even coming from Europe, it has great carbon sequestering properties to it, although there are products being manufactured in North America. So hopefully that will help reduce that in future iterations of this calculator. And then finally, we've got 5 inches of closed cell spray foam, which interestingly falls between the mineral wool and EPS and compared to the XPS. So somewhere within there. From an operational energy carbon perspective, we have a different picture for this case study because compared to the previous one, not only does this project use natural gas, but it's also in Alberta, which at this time has a grid emission factor that's much higher than Quebec. And also not only, well, for the electricity. So even though the natural gas carbon emissions was reduced by 58% thanks to the thermal enclosure upgrades, switching to a hybrid heat pump water heater, but the reduction of the overall emissions was only reduced by 40%. So you can see here the pre-retrofit and phase 1 retrofit results. Lots of reductions there, but still relatively high with respect to the tons per year. So lessons learned to sort of wrap things up. IDP, this is the best approach to help projects set it up for success. A roadmap can be developed with the end goal in mind, which allows for the development of a phased approach, such as the work done now is setting up for the next phase so that you're not doing more costly repairs for subsequent phases because they've already been thought through. Designing, so the Larsen Truss, it's an adaptable method, meaning that the essence of the original Larsen Truss allows for the project to modify the approach to suit the conditions of each project. It's an effective method to add meaningful amounts of exterior insulation with minimal thermal bridging, while effectively reducing the air tightness of the building, and presents a great opportunity to implement great water management strategies. All of these elements combine to extend the life of these buildings using readily available off-the-shelf products. There's synergy with air tightness and updating windows. When we look at the Larsen Truss, the exterior retrofits present a great opportunity to reduce air leakage, update the windows, or perhaps reinstall them, as we mentioned before, and significantly reduce the future risks of moisture-related issues by implementing great strategies like flashing and slope sills and stuff like that. Interior wall insulation, I put a question mark in there. Perhaps looking back at that first case study, if we had a more intensive, the first case study was more intensive with an interior and exterior retrofit, and it presented the question, well, maybe if the Larsen Truss was used on the exterior and all of the thermal control was added to the exterior, maybe the interior, there could have been some cost savings there. So, further analysis or identifying that potential in future projects. With respect to schedule, there could be time sped up with experience. So both project teams suggested that with more experience in using a version of the Larsen Truss on future projects, that the time required could perhaps be significantly reduced. But as we all know with renovations, you never know what you're going to get. But at least if the same strategy is used and replicated, then there's less of a learning opportunity the hockey stick curve of learning the ropes is significantly reduced. Ordering and supplying windows early helps, especially if in the sequencing of things, getting them on site and installed at the appropriate time can help with the schedule a lot, also for the mid-construction air tightness test, so that it sets that up for success as well. From the air barrier, redundancy is good, but can be expensive perhaps, or an opportunity to provide some cost savings there. A complete approach is great to achieving both air tightness and thermal control and reducing the heat loss for the entire building. Chainsaw retrofit was a great success in achieving both results in its completeness, although we'll see what phase 2 will show for the second project. And test often. When it comes to great air tightness, the more air tightness testing you can do, the better, and that will set the project up for success and make it easier to find and seal the leaks before they get covered up. So with that, I open the floor for questions.
Good. I've thrown a bunch of questions in there. I know there's one question that's not mine in there.
You're gonna have to speak up a little bit or get closer to the, come stand in the middle.
So, yeah, let's share their Slido screen again. So yeah, if you have more questions that you want to throw in the Q&A, throw them in now. Like I said, there is one question that I didn't ask, so we'll start with that one.
What's the Slido code again?
Oh, it is. Anybody else want to? And a couple of those written ones.
There, it should pick up if you scan that QR code.
I think if you go to the next slide.
Oh, I'm not presenting the right thing here.
There we go.
There we go.
I don't know, Stephen, if you can see that or not.
I'm sharing the wrong screen.
I can see the Slido,
Oh, you can.
but not on that screen. Well, let me see.
I just stopped.
I just see the Slido on my web browser, not on Zoom.
Okay. Yeah, I think if you look at your Zoom now, we should be able to see. And we actually just scroll down to the bottom because that's where the other questions are. So that first one, there's a question about the ACH. At what point does it make financial sense to consider the results good enough? So I think the question is, at what point do you say, like, is there cost savings to be had by saying that we're not going to go to the like a sub 0.75 ACH or as opposed to like a 1.5 ACH?
Right. Yeah. That's a great question. I mean, ultimately the goal is 0. But programs like Energy Star, Net Zero, Passive House, they all set boundaries or targets so that there's a wiggle room of varying degrees. But we are trying to get it as tight as possible. I think, how tight you need to get to net zero requires detached homes to get to 1.5 ACH, and retrofits, we understand that that can be challenging. So as close to 0 as possible. Ultimately, as projects get more experience with this, then the ability to achieve 0, depending on the specific project, ends up getting easier, as long as you have the process with which to implement air barrier strategies and test often. I heard recently that an example in the UK, they were testing homes, not with a target, but just to say we have to test homes. So mandatory air tightness testing for homes was put into place. What they found was that even without a target, people just got competitive against others and would just want to achieve greater air tightness. It's a sense of pride as well to achieve as low of a number as possible. So, how low do you want to go? As low as you can get, learning from past projects to then implement better strategies in the next project would be the goal in that case. So I hope that answers that question.
I think that the next one was with regard to the weight of the cladding. Just scroll
You wanna
down.
go start from the bottom?
Yeah, because
most recent
those
one?
top questions are all mine.
Oh,
So what cladding weight do you have to start worrying about the Larsen Truss structural resistance?
That's a great question, and I think even with the cement board, which is probably one of the heavier ones, I don't think there was an issue. It's not carrying a lot of weight in general, and the structure at the bottom and also tied in at the top didn't seem to be an issue. The beauty with the LEEP guides is that they do go through that structural requirements, which if Larsen trusses become LEEP wall number 5, it would all be covered under that. But if I recall correctly, even looking at the rock wool or mineral wool installation with screws and strapping, you could probably hang cement board on that as well. And with the right screwing pattern and the right screws, there's very little deflection, because now you're also using the so the resistance that the insulation provides to help carry the weight as well. So it's not like it's screws that are hanging out in the air. There's actually some resistance that the insulation product also provides. So with the Larsen Truss, I mean, the original Larsen Truss, there were anecdotes in my research to this that suggested that they were so strong that you could almost climb it like a ladder on the outside of one Larsen Truss. So from a structural perspective, I don't think there are many cladding materials that would be that heavy.
So the next one was, when applying the cellulose insulation, is it an open web or is it a compartmentalized bay?
Yeah, so that's a good question. They would, in the case of case study number 1, they created bays that were basically 4 feet centers. So every second stud would have some sort of closing to make it a compartment for the dense pack cellulose to be installed. I'm not too sure about Steve's project. I'll defer to him to provide his experience with that. I know when speaking with Peter Amarongan that it isn't compartmentalized within the bays of his method, and the cellulose providers are able to just dense pack it almost like as if it's just one big cavity. So it ultimately depends on the cellulose installers and what they're comfortable with the equipment that they have.
So for case study number 2 for the SNAP, what depth of exterior insulation was applied below grade?
Oh, I believe it was. It looked like two layers of 2-inch foam, but I'll have Steve correct me if I'm wrong for that one.
The depth, right, just go 4 feet, 6 feet.
Steve says a foot below grade for
Yeah,
those online.
Yeah.
Oh, the depth. Yes, sorry. Yes, a foot below grade. Okay, thanks, Steve. Appreciate you being in the crowd.
Yeah.
How are building officials viewing the placement of air barriers within the wall structure? Ooh, that's a good one.
Well, the funny thing with air barriers, if you're looking at an air barrier, it can be anywhere in an assembly. It can be on the inside, it can be on the outside, it can be anywhere in between. Where its placement is, where the placement of the primary air barrier is becomes an issue, is if it is also a vapor control layer. So if it has low permeance and is either a vapor barrier or a vapor retarder, then it has to be more on the warm side. But when we look at a Larsen Truss being added to an existing wall, whether it's 2x4 or 2x6, if you just make the Larsen Truss deep enough, just like with the original Larsen Truss, they would put poly there. And so that's where sort of that 1/3, 2/3 came about, and that falls within that. So that poly on the warm third side of the wall assembly thickness ends up being in the perfect location for it, which helped with the success of a Larsen Truss because it simplified that process.
Third one, when using the long screw to install rock wool and strapping, are you not worried about hitting anything in the walls such as electrical or plumbing?
That's a great question. You could be. Now, really, if you, I'd have to defer to the LEEP wall guide as far as that goes, but you'd only need to go in an inch and into the stud. So perhaps there might not be anything there. If that's a concern, maybe that's and you can't inspect the existing wall, then perhaps another strategy might be better if you're really concerned about that. But it is one of the risks. And from what I hear of people installing really deep insulation layers like that, it's best to create a jig because you do want to hit that stud, which adds to the complication of installing deep layers of insulation that the screws need to actually hit the stud. So yeah, things to consider.
It'll be a good discussion when we go over the wall library. We look at the different exterior options, and you can even see on some of the samples the amount of travel that the screws have. So
going through.
yeah.
If
So
you're out an eighth of an inch going through your strapping, you're missing that stud.
yeah. So that'll be a good discussion to have when we go to the other side there. Payback, i.e., do I do nothing versus a retrofit green in my?
Oh, can you say that again? Or maybe I don't have audio anymore.
Silence. Did we lose him?
I've got you back now. Your audio cut out halfway through your question.
Oh, I said, so the question is around payback. Does i.e., do you compare it to doing nothing versus retrofitting green? And it alludes to what's the feeling on the pocketbook versus the generally good feeling that you get. So what are your comments about the benefits or the costs of doing a deep energy retrofit?
Oh, that's a global question. Well, that kind of depends. If we, I think it's a missed opportunity if the opportunity presents itself. Like with a siding, if you're switching out siding, then the amount of additional costs to deal with the air tightness, the water control layers, and add insulation is minimal on the grand scheme of things. I think I've heard stats like it might be an extra 15 to 20% to add that insulation and add all those details when you're residing a project. So that's the perfect opportunity to do that. Would I say if a project has just resided, would we go to the expense of doing a deep energy retrofit? Well, no, because there's a sunk cost in that, and so you wouldn't go down that route for that particular project. But if the opportunity is there, take it.
A standard wood frame with studs penetrating insulation, the clear field with R20 nominal might be closer to R17. And what's the effective R value for this? So I think this is going back to some of your in the case studies, you know, what is the R value you're reporting there?
Yeah, so the original one, well, the case study number 1 had the 2x6 with R20 or R22. And so that had an effective R value of, I think, R20 once you added in all the layers, including that 3-inch solid plank. With the second case study, it was a 2x4. I think we may have used R10 or R12, and it had an effective R8.
And then with the upgrades?
Then with the upgrades, do you want me to go back to those slides? Would that be right? Well, I think case study number 1 ended up with the total effective R value for the walls of R47. Case study number 2 had an overall effective R38, if I recall correctly.
Those were the effective values you reported in the slides, not the nominals.
Correct.
Okay. And we will, just so everyone knows, I saw people taking pictures throughout. We are going to have the slides on the ENBIX website here this month. So we will have this recording and we will have the slides available for people too. So if you missed it, don't worry, we're going to have them back. Support for new versus retrofit home updates, professional services, carbon offsets, materials. You know what? I'm gonna defer this one. We're gonna have lots of conversations about that this morning, so there'll be opportunities for that one. Common ways of finishing the underside of the Larsen Truss overhang, and I'm gonna ask a quick question. Are we talking about at the ground level here is what we're talking about?
Yeah, maybe before below grade.
Okay, so Stefan, the question is common ways of finishing the underside of the Larsen Truss overhang before below grade, like just above the grade.
Yeah, so that's I wonder if I can get to that really quickly. That might be shown in this detail here, where there's.
We're on a different screen than you, hold on.
Oh, you are, that's right. Okay, so plywood, essentially, it really depends, but you want to stop, you want to hold the insulation in there and stop things from getting in there. And so a plywood base is probably a typical bottom.
What about cladding, just normal soffit?
The question is, what about, do you clad that plywood or just a normal softening on top of that?
Yep, the sky's the limit as far as what the aesthetics looks like for that particular location.
Wait, what about clearance from grade? So the question there, Stefan, was what about clearance above grade? How high?
Yeah, you would want to be aware of your particular location and the potential snow that could accumulate, but the general a foot above grade is typically the minimum, but it depends on the products that you use and things like that. You wouldn't want to get too close to grade and then have to use pressure treated materials, and so you would want to switch over, just like in case study number 2, where you have some a different installation method for the below grade section.
An interesting question. Would insurance premiums be reduced on the deep energy retrofit for the homeowner?
Well, that's a great question, and we would want to hope that that could be another value that a deep energy retrofit brings to a project to incentivize people to do that. But I haven't seen a case of that. I think if we have the ability to model hours of safety that are associated with homes, and a deep energy retrofit like this can assure a certain amount of hours of safety, not only for the occupants, but also from the risk of pipes freezing and stuff like that, I'm sure the insurance companies would ears would perk up at that, and insurance premiums would go down.
And I'll just add to that, like I haven't seen anything specific on that, but this is a frequent conversation we see around the influence of the insurance industry over our construction practices, particularly when we talk about resiliency. So that can be like wildfire resiliency if we're building in areas that are risk. You know, Southern Alberta, we're talking about hail resiliency. I think we saw in both of these case studies, we're talking about fairly durable exterior siding being applied that are going to have high survivability. So, and we talk about, from the insulation, we talk about passive survivability. You know, how many days does the home remain occupiable in a total power outage or an extreme weather event? So we expect that we will hear about these things from the insurance company. So it's a really good question.
Yeah, and if you're in an area where there are wildfire events every summer, then the amount of smoke that comes into a house that has had a deep energy retrofit or is new construction with super air tightness, then the risk of smoke coming into the house and creating fire damage inside the house, or toxicity levels that won't allow residents to move back in, from an insurance perspective, that's huge, because now the occupants are not displaced for a longer period of time. That might be an insurance cost, and they can move in much faster.
So for Larsen Truss, would using rock wool bats be a safer option than dense packed cellulose? And I'm assuming by safer, we're saying more vapor permeable. Okay, so would it be a more vapor permeable and more, I guess, like long-term durability option?
From a vapor permeability perspective, they're about the same. And mineral wool bats are hygrophobic, meaning that if moisture gets back there, it drains and then it's back to normal. interestingly, with cellulose, it's a high grit buffer, meaning that it can store moisture and then redistribute it within the assembly and then allow it to dry. So as long as the vapor control layers are chosen so that there's drying potential in either one direction or the other, or in both directions, then both perform in a very similar way from that perspective.
With all the effort to install the Larsen Truss system, how much impact do high quality windows and doors have on the effective R value of the wall assembly? And I will just plug answers. I'll just plug that the window technology, the LEEP window technology LEEP guide. We have recordings of that going up this month, and that dives deep into this question. Sorry, Stephen, go ahead.
Yeah, that's a great question. When you look at the effective R value of the total thermal enclosure, if you've got a high window to wall ratio, and it's important to understand the window to wall ratio of a particular project, because the higher the window to wall ratio, the more glazing there is, and the more impact it has on the effective R value of the entire enclosure. So if you have, and this is something that you'd have to figure out in the analysis portion of the integrated design process, where if you're adding a lot of insulation to the walls and the thermal enclosure, but you've got a poor performing high U value window, maybe it makes more sense to address the hole in the wall, which is the window that has the lowest R value contributor to the heat loss. So that comes out in the analysis, I would say, and it depends on the project.
We have concerns about rodent activity in below grade EPS insulation.
Personally, no. Steve, do you have any concerns about rodent activity in this particular project and the application?
I haven't seen it yet.
There you go. It's used often below grade, and so I haven't heard of too much happening with respect to rodents. Perhaps termites in the deep south, although it seems like termite activity seems to be migrating its way north. But even then, it's, you know, if that's a concern of yours in your particular location, that could be a good indicator to make the appropriate choice of materials for the below grade application.
So decreasing ACH is great, but what target ACH air quality should I ensure the HRV is set? So I guess, yeah, okay, so we're saying, what are your comments about how do we mechanically ventilate the house when we're building super airtight homes, and how are we designing for that?
Yeah, so both of these projects with their target of great air tightness also included an ERV or HRV to provide that mechanical ventilation with heat recovery and perhaps moisture recovery as well with the ERV. So absolutely, any project that is considering a deep energy retrofit or considering improving the air tightness should also be adding in a ventilation system with heat recovery just as a standard. That's a non-starter, which is one of the consequences of making the thermal enclosure that much better, is that there is this additional cost of adding in this mechanical system, but that's the best way. You want to build it tight but ventilate it right, and that would be a balanced ventilation system with heat recovery.
And Stephen, would they have done for these projects like an F326 like CSA F326 calculation for air turnovers and fresh air?
No, an F326 wouldn't have been required in a retrofit situation. I'm not too sure if Steve did that or if it was just a simplified approach and just tacking it onto the existing ductwork. With Felipe's project in Quebec, a full redesign was done. So a HVAC designer was used to redo the ducting, and so that was all specified by the HVAC designer.
Okay, I think the rest of the questions are just mine, so we can.
You added a lot, holy cow.
I know, I can just email.
You got a lot of questions, Phil.
I can just
You
email.
can have your own session.
I know, that's the privilege of being the host. So what we'll do, we'll take a 10-minute break here. When we come back, I'm gonna ask you guys a couple questions, and then we're gonna introduce Joad and Shannon from Airdrie and from Alberta Municipalities. We'll have a quick presentation on the CEIP program. So thanks to everybody online who's joined us. Really appreciate your time. And again, let's thank Stephen for our step.
Great, thank you very much, everyone.
Right, so it's 10:01, so we'll come back at about 10:10 and start again. Yeah, what are you looking for? Oh, I don't have copies of that yet, but so it's gonna be available. Let me give you. There's few experts in the room that might not think, so I appreciate that. Okay, that's it. Couple more coming. I'm gonna give it one more second here.
Yeah, you only got 11 participants.
Okay. So, one word that describes your feeling about the two case studies presented here. Bear in mind, Steve's at the back and he's listening closely, and Chelsea's at the front listening closely to see what you all say. Innovative, cool. Something. We did this, I asked this question, or one like this one, I did an air source heat pump session. And was asking before the presentation, like, what's one word about air source heat pump? And magic was the first one that came up. Like, all right, you're at the right session. Manageable, okay, I like that. Manageable is a good one for me, because that makes it feel like it's achievable there. Beautiful. I like beautiful too. I do admit, I love the picture of the Larsen Truss before you clad it, and you can see all of the trusses up on the wall. I think they look fantastic. Okay. So, actually, I'm gonna go back one here real quick. And so, before I introduce Shannon, I'm gonna introduce Joad from the city of Airdrie. So, Joad, if you want to come up, and Joad works on the sustainability programs for the city here, and he's been involved with the rollout of, which is very exciting that the city has now rolled out their CEIP program.
Thank you, Joe, for the introduction. Thank you, Kate, for the ENBIX and Retrofit Canada team invite. I'm Joad Tamat, Municipal Energy Advisor with the City of Airdrie. I lead the corporate community management program, so basically I look at the efficiency projects on corporate properties. I also lead as the program manager the new CEIP program, Clean Energy Improvement Program, we launched 2 months ago. We have received so far about 40 pre-applications, so people are interested in implementing home energy upgrades. There's obviously provincial regulation behind that program. It's a structured approach across the province. We are one of the latest municipalities joining this program. We received funding from the federal government to support approximately 260 home energy upgrades of different levels, ranging from $5,000, the smallest upgrades, all the way to $50,000 investments. And basically, we have so far yet to evaluate our first full applications. People are now getting the contractors quote, asking some contractors, are you participating in the directory, the CEIP directory? If not, then I refer them to Shannon, saying, make sure you are listed there so that you have done the due diligence process. So basically, we're launching, very exciting. We have touring and marketing materials on our bus running around town, and people have been starting to call us for more questions about the program. If you have any further questions, I'll be glad to answer yours. And Shannon will talk more about the details of the CEIP program for contractors.
Yeah, so we're really lucky to have Shannon here today. So Shannon's with Alberta Municipalities, who runs the CEIP program throughout the province. Shannon does this wonderful presentation to contractors to talk about kind of some of the things you need to understand about how to manage this work and how it works for you. And that over to Shannon.
Thanks, Joe. Awesome. All right, thanks for sticking around for this presentation. So you guys talked a lot about, the technical aspects of these retrofits, and also I was happy to see just the cost of these retrofits. That's obviously a huge component of the choice to go with that kind of an upgrade. So this is kind of the province's response to this choice for homeowners. Is the Clean Energy Improvement Program. So like Joe had said, it is provincially regulated. So there is a regulation that outlines what the Clean Energy Improvement Program is. So it slightly differs between municipalities, but in general, there is kind of you'll see a very common theme between municipal programs. So I just like to first acknowledge that we are in Treaty 7 territory here in Airdrie, and in the province that we call Alberta was originally home to many Indigenous folks before us, and we're very lucky to be able to work, play, practice our professions here. And I'd just like to acknowledge that we make this as an act of reconciliation, gratitude, and commitment to pursuing an inclusive, collaborative, and respectful path towards building a strong communities in Alberta. So in case you don't know, Alberta Municipalities was established in the early 1900s and has been serving municipalities across Alberta since then, in all sorts of different ways, from advocacy, providing insurance, down to benefits, and also Clean Energy Improvement Program and Municipal Climate Change Action Center. So we basically partner with municipalities to provide them these services across Alberta. All right, so there's going to be kind of two parts to my presentation. The first is going to be all about CEIP, and some of you guys are already qualified contractors, so you'll be very familiar. This will be a bit of a review for you. And then the second part is going to kind of hone in a little bit on those who have some experience, just what can help streamline a project. You might have noticed there's like some things that can really, prevent payment going out efficiently. So I'm going to give you some ideas about how we can streamline those so you get paid on time and projects move forward in a timely way. And if time permits, I might navigate to the portal. I guess I don't have my computer hooked up, so maybe not today, but you can see that in other recordings as well. So the Clean Energy Improvement Program is a little bit different than other financing tools. So it is a financing tool, but it's property tied. So it's not tied to property owners. So it's not a credit tied tool. It's actually tied to the property itself. CEIP makes it easier for property owners to do larger scale, deep energy retrofits and renewable energy projects. And it's a municipal program administered by Alberta municipalities. So there's a central administrator, and then each municipality has their own program. So just like to highlight that you basically have access to a broader range of customers, because people now who might not have been able to afford a deep energy retrofit have access to financing that they can't easily get at such a low interest rate through typical financing routes. So why do you need to be a qualified contractor? The Alberta regulation outlines the requirement for qualified contractors. They have to be listed on a central directory, which is the contractor directory on the CEIP website. All services provided under the program must be done by qualified contractors, including installers, professional service providers such as engineers, incidental work contractors, and subcontractors. And another key thing is that qualified contractors can't enter into any other agreements other than the project agreement that is provided by Alberta municipalities. So basically, we've got a very comprehensive agreement that is signed by us, who will be paying you, yourselves, and the homeowner. And that's your main agreement for any CEIP project. We have that sample agreement on our website and on the contractor portal. And again, you have to be listed on the directory to provide services. This is the main area that participants will come to look for a contractor. So the benefits to you, again, it's increased visibility. All participants they're given the link to the directory right up front. They go to the directory and can search based on their municipality. So you'll state where you provide services, and they can search for you there on the services. Or they can also just search directly for your name. If they know the company and they want to find you, they can find you there. You've got a support team. That's us, Alberta Municipalities, and also Joed's team is really amazing at Airdrie. So you've got technical support for the financing side of it, and municipal support for any specific questions that are specific about the municipal program. And so, yeah, we're there 8 to 5. We've got an awesome experienced team there at Alberta Municipalities. Thirdly, lastly, there's more business. So customers, again, can make more ambitious projects. They can finance up to $50,000 for energy retrofits. So just to give you an idea from like the Alberta wide scale here, we're working with many of the major small and large municipalities in Alberta. In 2025, we just launched, like Joad said, we just launched Airdrie and Banff. And we're still looking to launch Beaumont, Slave Lake, Spruce Grove, and Wetaskiwin this year. But already we have all of these 23 active programs across the province, north to south, east to west, and yeah, it's only growing from here. So just to say, we're here to stay. You're going to hear more and more interest from people about these programs. And it's supposed to be a long-term program. It's not one of these like boom and bust cycles that you get with a lot of the grant programs. And right now we are working with municipalities to get capital financing to extend their programs beyond the initial 4 years that it was set out. And also to give you an idea of who we're working with from the contractor side, we've got more than 500 contractors onboarded already. In the process of onboarding another about 150, and it's just growing constantly. So my team is growing as well. It's been great. And right now we have 800 active projects, over 800 active projects, almost 600 complete projects, and like just so many completed upgrades. So there can be many upgrades for one project. So when Joad said Airdrie has, I think, 250, so 250 projects are available, which could have multiple upgrades per project. So far about 1,400 complete upgrades through the CEIP program. All right, next we're going to just jump into a bit of a roadmap of a typical project. So it looks like a lot of steps, but for you guys, you're really involved in a few key steps. Obviously installation, quoting, and getting paid. So we're going to walk through it a little bit, and I'll just highlight where you guys will be involved. So first, a few steps here are pretty participant heavy. So it really is a participant-led program. There have been programs in the past that were really led by contractors, and we got the feedback that that was too much. It was an extra burden on contractors, that there's a lot of administrative work that they didn't want. It was a lot of non-paid work as well. So we kind of shifted when they designed the CEIP program to make it more participant-led, which makes the burden be more on us, like the central administrator, to coach people through, which is fine. That's why we've got our staff. So that's what we do. Pre-qual, the pre-qualification stage is where the property owner submits a pre-qual application on myceip.ca. Takes about 5 minutes. It's very, very brief. And that's basically just to determine if the property is eligible for CEIP financing. So for example, if they're a brand new homeowner, they just moved in and they don't have any equity in the property, then they don't have any borrowing weight with the municipality. So there has to be some, they have to have some equity in the property to borrow. Second is the home energy evaluation. So they'll get an EnerGuide done to their home. And then from there, they can have a conversation with their energy advisor and select which upgrades make the most sense. They'll pay for the contractor, or they pay the contractor directly for that evaluation, but they can finance that if they save the receipt and ask for financing to cover that cost. Third is when you guys come in. So they're going to select the contractors from the qualified contractor list, and then they'll be submitting an application. That'll be step 4. So basically in step 3, they've already had the pre-qual, they've been approved by the municipality to go ahead and select the contractors and submit an application. So some eligible upgrades here are listed. So basically all HVAC has to be ENERGY STAR rated. Windows, doors, and insulation. Windows and doors also have to be ENERGY STAR rated. I like to highlight that because not all contractors sell ENERGY STAR equipment. So when CEIP participants come to them, they just have to make sure they're providing that participant with ENERGY STAR equipment. Solar PV and solar thermal, lighting and controls. Lighting again has to be ENERGY STAR rated, and permanent fixtures. Ground and air source heat pumps, and water heating, again, ENERGY STAR. All upgrades have some requirements. Those are listed on our website. And by requirements, it just means like ENERGY STAR rating, specific AFUE values, or energy efficiency ratings. So those are all outlined on our website. So step 4, as I was alluding to, is a project application. So this is where you've basically provided the participant with a quote and spec sheets for the equipment that you've got on your quote. And the participant then accumulates all of the quotes that they got for their different upgrades. So they might have windows, doors, and solar, let's say. And they'll have all of those on a quote submits that to us, we do a quick review of that. And by quick, I'm gonna tell you now, it's about a month. We're really busy, so it's about a month. If you give a quote, we do ask, one of those tips is to extend your, the quote expiry if possible. We recognize that some things, you can't give more than 30 days, that's fine, but we are probably gonna be calling you and, hey, like, can we extend this to a 60-day or 90-day if possible? So it helps if you can have that on the quote, that it's good for 90 days. That's step 4. One quick thing too is just that if you are operating in the city of Airdrie, you have to have a business license, so make sure you do that as well. Step 5 is application approval and installation authorization notice, also affectionately known as the EN stage. So this is when we've approved it, the municipalities approved the application, and they've basically secured that funding, they've saved that funding, put it aside for that project. So that's your money basically guaranteed as soon as upgrade completion has happened and everything's been approved. So just to say, you guys are going to be getting paid. It's not up to the participant now at this stage to provide that money. It's up to us, and we've got it set aside by the municipality. So at this stage, we review all the application forms. This is when we might be getting in touch with contractors if there's any missing information. More on that later. And this is where you'll also be signing the project agreement. So no work can start until that document has been signed, and then the EN goes out in an email to everybody. So the participant and the contractors all get the green light all at the same time to go ahead and book those installations. So warranties are required from contractors. I think this is all, it's pretty standard. So basically we require that manufacturer and suppliers warranty standard with just industry standards with a period of at least 1 year from the time of installation. And it has to be transferable to subsequent property owners. That might be a little bit different, but it does have to be transferable because it is property tied, the financing is property tied. Some upgrades have additional warranty requirements, such as solar PV. They have to have a 25-year minimum warranty period. And contractors must provide a warranty for defects in materials and labor of not less than 1 year, which is pretty standard again. A little bit more about the project agreement. So it's a tri-party agreement. 3 parties are signing it. Replaces any other contract. We really like to nail that one home. And it's there to protect you guys and the participants. Basically, it outlines what happens if there's a dispute. There's a dispute resolution process. I also get involved in issue escalations, favorite part of the job. And but basically, it outlines what tools you have available to you in legal regards. So other components there, it outlines the warranty requirements, insurance requirements, direction of pay. So some quotes can be more complicated, like the participant is eligible for 50,000, but the project is actually 75,000. So it'll outline what money is coming from us and what money is the responsibility of the participant. So that's all included in the project agreement. If there are completely ineligible costs, so anything that's not an energy efficiency improvement or renewable energy addition to the property, those would be considered ineligible and those won't be included in the project agreement. So good segue here. So eligible costs and financing terms for the CEIP program and for specifically Airdrie's program. So if you are working in other municipalities, this is the slide that's specific to Airdrie. So Airdrie is allowing 50% deposit, which is great, of capital costs for the eligible upgrades. Also, they're financing professional services and incidental costs. So incidental costs, we're using that term to refer to upgrades that have to happen in order for that upgrade to be installed. So roof repair for rooftop solar is a common one. Another one we had was you might have to upgrade the wall in some regard for insulation. Siding is also considered an incidental cost, kind of unfortunately. I battled for that one to be a capital cost, but because it doesn't improve the energy efficiency of the house, it can't be financed under this program. So it would be considered an incidental cost. So only 15% of the capital cost of the upgrade can go towards siding.
So an incidental cost, even if you're doing like an exterior insulation, the siding would still fall under the incidental.
It does, yeah, unfortunately, I know that's going to be key for you guys, but yeah. So anything to do with the siding, you know, all of the wood material, that would all be considered capital. but the exterior cladding would be incidental. The financing term, so this is a good one, actually, because, you know, you guys can take a picture if you want. The interest rate for participants is 2.75%, probably lower still than what they are able to get at the bank. So that's really the key here with when you're borrowing from the municipality, you are able to access those lower interest rates. And there's a maximum term of 25 years at Airdrie.
Is that interest rate tied to prime? Like, so prime moved down, does that interest rate? go
It's
up?
not, so this is a fixed interest rate. Yeah, it's a good question. A minimum capital cost for projects has to be, so it has to be at least $5,000 and up to 50,000. That can be, so $5,000 could be installation and a heat pump. It doesn't have, like, if it was just installation, which might come in at 2,500, they can just pair another upgrade and reach that minimum 5,000.
I just have a quick question.
Yeah,
Regarding the interest rate, is there a plan to revisit that during the program?
Joanne?
This rate is guaranteed for the next 4 years, so we will probably reassess in 4 years.
Okay,
So the city of Airdrie has also got, yeah.
Just deep there, are you revisiting the interest rates that the customer has at 4 years, or is that 2.75 guaranteed
No.
25-year term?
It's for 25 years, but in 4 years, the rate might be adjusted to the
The
new,
program.
In a new contract.
to the new price.
So a new.
So there are some incentives available, a rebate of $600 for all CEIP completed projects.
Can you define what you mean by that?
So-
As an energy advisor, does the cost of the evaluations cover that?
Does this cover the cost of evaluations? It depends on the cost, but generally, a pre and a post together is about $750 around there.
Yeah.
So that won't quite cover the cost of the pre and the post, but
But this is geared towards covering the cost of the evaluations, or is it something overall?
it's just overall. So this is gonna go against your total borrowing amount. So it's not like a check or anything that goes to a contractor or goes to the participant, it just reduces the overall financing on the tax roll. And then additional $2,500 is available for completed CEIP projects that have financed more than 15,000. So this is really geared towards, you know, your crowd as well. So this is your clients who benefit from something like this. We're doing deeper energy retrofits. They can get $2,500 for doing those deeper energy retrofits. They have to install 3 or more upgrades and at least 2 of energy efficiency, renewable energy, or fuel switching. I thought this was so innovative. Was this you, Joette? Did you come up with that one? It's great. So if they're switching from being natural gas to fully electric, that would be eligible for that rebate. They're limited, first come, first served, and 1 incentive per property. I believe there's 1 incentive for the 250, for each of the 250 projects that you have budgeted, right? Or is that not guaranteed?
No, it's first come, first served, so we don't
Okay.
have those, the 2,500 for all those
Right.
projects.
Okay. But incentives can be stacked, so if they're participating in other programs, they can stack those incentives with those programs as well. And again, it's reducing the total project financing.
I just have a question about, and it's probably to Joanne. You may find that requiring 3 upgrades may target the more affluent sites. If you're trying to be low income, I don't know if you have an alternative option for those.
Yeah,
where They
so
might be given a threshold where they can be given 1 upgrade.
yeah, it's a really good point, and it's something that we're really aware of, and we talk about it with municipalities as well, that financing tools in general are not really the best for lower income folks,
Right,
because a lot of lower income people aren't interested in getting more debt.
yeah,
So financing tools are tricky. You know, incentive programs are really great for that demographic, but we're right now like working with programs across the country, trying to figure out how we can also have this stream that's tailored to those folks as well.
yeah, like you're probably familiar with the cooperatives, like
Yeah.
Spice and Bow Valley, right?
Right,
Where
yeah.
people can either put money in and still get 2% back kind of thing, if that's how they want to contribute.
Yeah, so, yeah, this might not be the right tool for them, but
Yeah.
we recognize that maybe some innovation is gonna be needed in the coming years, for sure. Yes.
For the greener homes and starting up with that program, how does that work, like in relation to how the funding comes from what program first? And then the top up funding,
Yeah, it's a great top-up funding.
like for instance, you have a $70,000 project.
Yeah.
That extra 20,000, does that kind of, does it just depend on, like, how does that work?
Yeah, so I think if I'm understanding your question, basically, there's a lot of folks who are doing this in conjunction with the Greener Homes program, whether it's the grant or the loan program. The grant program is now finished, but some people still had been approved for it, so they get to finish their project. The timing is different, and it's not a problem. We are so used to it by now. Like there are a couple things that people need to know with Greener Homes. Greener Homes requires a paid invoice to release the money to the participant. So in that case, they have to wait until they get that payment from us, and then they can show that to Greener Homes, and then they get the rest of the loan or the grant that they had applied for. So there's some navigating to do. We aren't experts in Greener Homes, so we always say if you have questions about Greener Homes, please, ask them, but we are experienced with the stacking of programs for sure.
Do you see more people take advantage of the full greener homes because 0% interest and then topping up with your program, or because of the benefits like the $2,500 in rebates, the advantage of your program first and then topping up with greener homes?
It's a mixed bag. Yeah, it really depends, because some people, so yeah, I guess we can do a real quick comparison of the programs. Greener Homes is, let's do the Greener Homes loan program is really a good comparison with our loan program. It's a financing tool as well, rather than the grant program, which is over now. So the Greener Homes loan program is, they get 0% financing for 10 years. It's tied to their personal, like their credit. Our program is up to 25 years financing, low interest rate, 2.75 in Air Green. And it's tied to the property. So if the property owner moves and they have a Greener Homes loan, they're still paying off that loan. They don't really get the benefits that they, that they've loaned that money against. They don't experience those energy efficiency benefits. Ours, like, these are just pros and cons. It's not better or worse. It just depends on the person. For CEIP, if they move, it stays with the property, and the new homeowner takes over that loan. We've had about 5, maybe more now, properties successfully sell with a CEIP loan on it. About half have kept the loan on the property and they just pay it through their taxes, and the other half asked for the original homeowners to pay out the loan. So far 50-50. It's been not a big deal, but those are the differences. Does that help? Yeah. Okay.
Yeah, I would just point out with the NRCan, it's not transferable.
Yeah.
So if
exactly.
you sell your home in 2 years, you have to pay it out and figure that out, or basically say to the homeowner, I got this money, I need to be paid somehow to make it move.
Yeah, in the back.
Has Alberta or Alberta Munis or the National Organization for Municipalities done any research with real estate experts on what CEIP does for the valuation of the home, and like that scenario you just described? It was really interesting to me because I never heard about that happening. So.
Yeah, that is kind of our next target audience. If we're being honest though, real estate agents do not like CEIP because it's just more work for them and there's no payoff, basically. But that being said, it does depend on the upgrade too. Like what you guys are doing deep energy retrofits, that, I mean, we're in this transition period where some people are super aware of their energy efficiency, the ratings, they all, like, people are getting EnerGuide ratings now. Like I just bought a house, got an EnerGuide rating. I'm horrified. Might need to employ some of you guys, but like, that's now on our door, and like that's going to be known for anyone who comes through our house. And it's just, there's a better awareness, and then there's also a whole group of people who have no interest, don't know anything about it. When we were talking to real estate agents, when we were looking to buy a house, so many just had no concept of energy efficiency, energy savings. It was not a conversation. So that's what we're trying to bridge the gap now as an organization, is having those conversations and educating, but it's going to take some time.
So what about the appraisal industry as far as it's concerned? So if you invest, a significant amount of money in your property, Is it gonna increase the value of your house, or is it gonna stay the same as the neighborhood that you're living with?
Joanne's
So
got a
the,
comment
so
on
the
that.
appraisal industry also probably should be targeted as well.
Absolutely, yeah.
Yeah,
Joanne,
I've got two comments here. So the first one, regarding, well, just the last one, where taxation department just started to look at numbers. We had 4 data points last year, so not enough results to make any conclusion, but yes, there was some increase in the home value. It was interesting for a taxation point of view that we actually increased the value of your home through those upgrades. The second piece regarding the equity and how do we help address that fairness in the home energy upgrade. The city of Calgary has done quite significant work on that. And I'm not sure they have published yet their reports, but they would really want to try to see how they can address the equity issue with those home energy upgrades and making sure that the poor or the poor household are not left behind that process. So we couldn't yet have a full resolution to the problem, but they were presenting the debates, and there is information on their website.
So question for you on that, if you're increasing the value, let's say Calgary comes out saying the value of the property side now increased, are you guys gonna be adding more tax on that property because of the value, or are you guys gonna factor in the fact that we're being energy conservatives and then we get a decrease in taxes? How's that approach?
That's the question we're gonna ask ourselves. Everyone will be asking that same question. I think some numbers in California have pointed towards that trend where those homes have more value, so they should be assessed more. How do we not desensitize people to implement them upgrades, knowing that they will have a value? That's a question for all of us to answer. We don't have an answer yet.
Yeah. Great questions. All right, so this is just kind of like a summary of what we just talked about, but before work can begin, for you guys to know, the project application must be approved, so it's signed. The project application, which is the quotes and all the supporting documents, those have to be approved by us and the municipality. The property owner and the contractor have to sign the project agreement. And then you have to receive that installation authorization notice, which comes in email to the participant and the contractor. And just a reminder too, all permits must be applied for and obtained. Because this is a municipal program, you do have that municipal oversight of all of these upgrades. So if there is a permit that's required for, Larsen Truss projects, because you're changing the wall, the structure of the wall, or you're taking out a window and putting in a bigger window or smaller, like that might require a permit. Know these things, apply for them so that it doesn't delay payment. We'll talk about that more later as well. So the last few steps of a project roadmap here is the upgrade completion and then payment. So the upgrade completion form is basically the property owner signing off on the work that's been done. So they're saying, yep, happy with the performance of the upgrade. It's working as intended. So there's no leaks. We had rain last night. There was no leaks in this new wall construction. And installation has to happen within 6 months. The upgrade completion form also has to be submitted with supporting documents. So again, this will be an invoice stating what was installed. That should basically match the original quote. If there's anything different, that's fine. We can issue a change order, but the sooner we know about that, the better. And then payment can come out after that. Once the documents are approved by us, it goes to the municipality, gets approved, and then we pay you guys directly. So contractor payment, yeah.
Sorry, back up and thinking, is there any other specific like commissioning or verification? Required?
No,
Do you require areas just to prove things or anything?
there will be a post, a retrofit, and our guide done. So that would test air leakage, but nothing before payment to you guys.
Sorry, I just have a comment on that. If your permits incorporate stuff like decks and other things, and how to close that permit available in the road.
Right.
So specifically like on the Larsen Truss, CEIP will pay for all the installation, but you then need to also complete all the siding and anything else that's incorporated into your permit, which can be a pain in the ass.
Yeah.
Things like decks, concrete piles.
Right.
Until spring.
Right. Yeah, that's a good point, especially with the work that you guys are doing, which is a little different than a one-off HVAC upgrade, right?
Or if your electrical and permit incorporates your heat pump, or electrical upgrades you're doing, and then wait till after it's closed.
Yeah.
Separate it.
It's a good question. I don't know, Joelle, if you have any insight to that, because every municipality is slightly different in that regard.
No, I don't have insight, at this point, we have not. We've gone through that process.
Yeah. We have come across that a few times in some bigger projects in the city of Edmonton, for example, where, yeah, their permits include several upgrades, so it is a challenge, and that's a good feedback. I'll take back to the team. Maybe there's something we can do about that. It might be on a municipality to municipality basis.
Maybe just hold the 10% until permits are closed.
Yeah, the thing with the 10% holdback, which I believe is on this slide here, yeah, so we do follow the the Prompt Payment and Construction Lien Act, which is an Alberta regulation. Which requires that we hold back 10% to ensure that no subcontractors have basically put a lien on a property. Holdbacks are only for that purpose. We will not hold back funding to a contractor because a participant after that initial payment, say the participant says, oh, actually that window is leaking, please hold back that 10%. Like, that is not the purpose of that tool. So we only will hold it back for that 60 days until, and then if there's no lien, then it's automatically released if there's just no other condition for that. So yeah, that's unfortunately not the right tool there for that, but so just to get into more of this, basically the city of Airdrie will not provide funds until an upgrade has reached substantial performance, save for the deposit that they've agreed to. If there is a deposit, then that gets released as soon as that installation authorization notice email has been sent. So you guys get the green light, you get a deposit, and then you're good to go. And then payment is made within 28 days of receiving a complete upgrade completion package. So what that means, or it's supposed to be 28 days from the point of receiving a complete invoice. So if we get an invoice and all it says is energy efficiency upgrade, $28,000, it's not enough. We have to have an itemized invoice, and I'll talk about that more later, but basically payment does get held up if the invoice and the supporting documents are incomplete. The last stage here is the post-project home evaluation. So this basically bookends the project. You guys have already been paid, so you're off and onto your next projects at this point. But the interguide evaluation kind of shows then the difference between the pre-upgrade, post-upgrade, and that's used for reporting purposes. And then the clean energy improvement tax is added to the tax roll and repayment begins. So at this point, the participant will have like a pending tax item, and then it'll come on whenever you guys do your taxes. Is it in April? Do you guys do yours in?
It's in June.
June, okay. So yeah, once a year, it'll be updated to have that new line item. So for you guys to become involved with CEIP, if you're not already, I know a few of you guys are, so thanks for participating. All you have to do is submit an application. It takes about 5 minutes to do that on our website, myceip.ca or ceip.abmunis.ca. We approve the application. It's very quick. There's an onboarding process where you will log into the portal, go through some modules that just basically reiterates everything we just went through. It's really, really great. Whoever's going to be kind of your primary contact at your company to do the module training so that they understand the program, they understand what is required on the invoices and the quotes. This will help streamline things. So if you have a program or an administrator that you want to have do the training, and if they are, they move on to another job and you get a new administrator, have them log on and do the modules. This will help too. And then you get listed on the directory once your onboarding is complete, and you can provide services in any CEIP municipality. So all over Alberta, once you're a CEIP contractor, you can participate in any program in the province. So this is what the application form looks like on our website. This is the directory. Feel free to take a picture of the QR code if you'd like, but this is how you're going to be listed. So on our website, basically it's a very user-friendly directory. All right, so that takes us to part 2. Are there any questions from part 1 from the project timeline? Yeah, go ahead.
Can a contractor owner buy this to their own home?
Absolutely, yeah. The only difference that you basically participate like any other participant, but you have to just provide a warranty for 2 years on the labor and materials. Yeah, I think it was here.
Do you have a desirable closeout time frame?
So yeah,
Start
installations have
first.
to be done within 6 months. You can apply for an extension. You just have to let us know, and then we would ask the municipality. Generally, it's a yes, please, take some more time if you need it. But yeah, so 6 months.
For contractors that work out of multiple jurisdictions, it would be nice to have a quick compare about the different requirements for using this.
Do you have that? Yeah, so yeah, on our website, that's a good idea, we did it. There's something on the portal, actually, it's called the quick reference for CEIP. So it's a really great, it's like a double-sided but one-page document that you can give to your staff or participants or clients. Or yeah, your admin staff if they're answering those questions. It's a great one pager. We also have on the back, there's a table that shows, it's also on our website. There's a table that shows every municipality, the interest rate, the deposit that's being allowed, and launch date if they're pending. Yeah, I think, yeah, in the back.
Just 2 questions. One is there a minimum amount of time you need to have owned your house before you apply?
Yeah, so it has to be occupied for, no, so a new house has to be occupied for 6 months before it can have a CEIP project. You have to have at least 5 years of tax payment history, whether it's this house or a previous municipality or a previous house in the same municipality. Right, is that the same? So every program's a little different, but yeah, 5 years.
So 6 months, okay. And my other question is, homeowners often want to do, you referenced the non-efficiency upgrades. Many homeowners are actually, because it's such a significant intervention on the house, they're also doing things like putting in an addition, putting off. And how much detail, how complicated is it to factor in the ineligible versus the eligible, what kind of documentation is required for that?
That's a good question. And for additions, so CEIP cannot be used for financing for additions. The obvious reason is that it doesn't improve energy efficiency to add on to your house, obviously. So this might get a little complicated when you're talking about like building a wall assembly and how you have to split up those costs. But yeah, I would just say do your best, and it'll probably be a phone call in the end with us anyways, just to itemize those costs. Yeah.
So how does CEIP deal with buildings that are on land set whereby you lease the land, such as First Nations or a trailer park or something of that sort of nature, and where you don't own the land, but you own the building?
Could be like a mobile home or something.
Correct.
Yeah, so I believe with Airdrie, mobile homes are not eligible. I'd have to double check. But the property does have to be owned by the property owner, I believe, like the property has to be owned.
So how do you as an entity, as a provincial entity, deal with that, and maybe even First Nations? So there's people who own properties on First Nations land and may want to participate.
They have to have a CEIP program in that municipality to start, yeah.
As a province reaching out to First Nations.
That's a good question. I'm not sure. So my counterpart, Stephanie Ripley, she's the municipal recruitment team lead, and she would be the one to ask about that. It's a good question though. Yeah, I'm not sure if we have any specifically First Nations involved yet.
I have a piggyback question.
Yeah.
How do we get our municipalities involved that are involved yet?
Yeah, so talk to Steph. I think I have her business card, but Steph does all the onboarding for municipalities. Who have you got in mind?
Right there.
Oh, okay. Yeah, they're in talks with Steph. Yeah,
Okay.
yeah, they're somewhere down the line. Yeah. Okay, so part 2 is just about streamlining. So this is, if I could just do a presentation just on this for 5 minutes, that's all I want to tell contractors, because I think this is the most important part. So your quotes and invoices have to include the eligible upgrades. So if you're installing insulation, we want to know everything about that insulation, because that's what the energy efficiency upgrade is. That's what's being financed. So we want to know the make, model, type, and efficiency rating, or R value, ER for Windows, And if it's an HVAC, we want to know the capacity. So that's basically it. It's not super complicated, but that's what's going to make the difference between a streamlined approval of a quote versus not, because we're going to have to go back and forth to get all that information. For like rim joist installation, we want to know the square footage. Actually, also for wall installation, we want to know square footage and attic insulation as well. So we want to know the pre-square footage and then the post square footage of what was actually installed. Spec sheet sent with the quote, please. So yeah, spec sheets for the installation. If you're doing a wall upgrade, deposit and milestone payments. If you're asking for deposit, just make sure that's outlined on the quote. One thing to note too is this will be relevant, I think, for this group, is that the deposit is 50% of eligible upgrades. So you might have a requirement of 50% deposit on your overall quote, but only a portion of that is actually eligible. So then there would be a portion of the deposit that has to be paid directly by the homeowner. So we outline that. We will do the math on that. Optional costs included on the quote, just let us know which option they went with. Otherwise, we'll be calling you guys. And again, that expiry date, if you can allow an extension, that's really useful. If not, we totally understand. And then, so if it does expire, then we would just ask for an updated quote by the time we are going through the approval process. So that's basically it. This is a really good one to take a picture of if you're participating. So top 3 causes for delayed payments are change orders and direction of pay change is the first one. Just let us know if there's any changes to a project. We can get that change order going. The sooner the better. If it's at the end of the project, unfortunately, that will delay payment. You can send that to application@myseat.ca. And then sharing the original project agreement with relevant staff. So usually there's one point of contact. We call them the primary contact at a company. If that's the only person who knows about the project agreement, but everyone else is doing the sales and the installation and the quoting and invoicing, then that poses a problem because they're just doing their normal agreement. So we want to make sure the project agreement is shared with the relevant staff so they know where the money's coming from and the timeline around that. Permitting issues, as we outlined before. So this does come up. So basically, yeah, the qualified contractors are responsible for obtaining all permits. Sometimes homeowners are responsible for pulling them. So just make sure you've had that conversation, like, please pull the permit so that we can get paid. Just have that conversation. It's really makes things go a lot faster. And then lastly, missing documentation. And this might have died. I'm not sure. Thank you. Appreciate it. Yeah, so if there's anything missing, so at the upgrade completion phase, we also do require photos. Some of the photos that were taken or shown earlier today, those were perfect. Just being able to show that staged completion of the upgrade. Product model number labels. So if you're doing an HVAC or a water heater replacement, we want to see the model numbers just to match with the quote or the invoice that you've provided. Energy efficiency stickers on windows and doors. That one really can stall projects a lot if we don't have those stickers. So those can come from manufacturers directly in a PDF. It can be a sticker photo on the window. However we can get them, we require those. Energy Star ratings. So those are the main things that caused payment delays. So if you can help with those, then you'll get paid faster. Okay, we really are. Thank you. I think we're just, oh yeah, and then that brings us to the contractor portal. So I won't necessarily go into this today, but basically there's a portal on it. There's a resources section and there's a lot of resources there for you guys, including the CEIP qualified contractor logo or check mark, basically stating that you are a qualified contractor and you offer CEIP services. On there as well, there's a quick reference guide for you guys. That's that 2-pager or that single double-paged quick reference. This is where you can have several people from your company log in and access these things. So you can add users to your portal. You can add contacts so that we know who to communicate with from our team. There's also marketing material. And coming in 2025 soon, actually in like 10 days, we'll be launching the participant portal, which will eventually be connected so that you guys can see what projects are coming. You'll see when your payments are coming. Should allow a lot more transparency about what's delaying anything and so on. Yes,
Can you just take pictures of them stickers on the windows?
yeah, yeah,
So that once the
Great.
windows are installed, you can go around and take pictures of all
that's
that?
perfect, yeah,
Okay.
absolutely. Yeah, so just to recap, we talked about what it means to be a qualified contractor and what CEIP is. So it's a financing tool tied to the property. Project timeline, so there's about 8 steps, probably about 4 of which you guys are directly involved. Payment, which happens 28 days after receiving a complete invoice, and then we hold back 10% for 60 days. To make sure there's no liens on the property. Next steps is just to go to our website and fill out that form to become a qualified contractor and do the onboarding. We talked about quote invoice requirements ad nauseum, so thanks for listening to that. And the top 3 reasons for delays and tips for streamlining. Thank you so much for your attention and for all the work you guys do. We really, you guys are doing big work, and it's really exciting to see a growing group of people doing this work. So yeah, thank you. And any questions?
What about like successive projects?
Like, can one property have multiple projects, like one after another?
Yeah, and then is the financing tool just however many projects to a maximum of $50,000 or?
Yeah, so Joy, correct me if I'm wrong, but property owners they can complete a CEIP project. And then once that line item is added to the tax roll, they could do another one. Is that correct?
I believe so.
Okay.
However, the second round, they will be no rebates, so there is an incentive for them to package everything together in a single application.
Right.
And is that how it works, or can you do successive projects with up to $50,000 finance?
Can you exceed the 50,000 before you?
Oh, like, do you do, like, if you did a $10,000 one, could you do a $40,000 one, or can you do an entire other $50,000?
Yeah,
I see what you're saying. I believe it depends on the amount of space they have against the borrowing power they have against their home. So if there's at least that much equity in their home, then they can, but if there isn't space there, then they would be able to. Does that make sense? So if,
for the $50,000 project followed by another $50,000 project, as long as there's enough equity in the home to excuse it, CEIP would do it, is what you're saying.
I believe so, but it's also a municipal decision, so.
No, I think it's the provincial regulation doesn't allow more than 50,000 at all. At the moment, it might change in the future.
Oh, okay.
I think it's perhaps something your team should explore, because there's no deep energy retrofit that will be less than 100 to 150.
Yeah, for sure.
Yeah, the city of Edmonton is trying to address that problem. They're the kind of leader in that field at the moment, so they're trying to push that limit up. The problem is also about the equity and how people, we want to make sure they're able to fund back the loan, basically.
Yeah.
I think the city of Calgary is also exploring something as well with retrofits, and that was part of the conversation too, about the cost.
Yeah, I wouldn't be surprised, because both cities are they really want to go towards deeper energy retrofits, which is what you guys are doing.
I think both cities have surveys circulating right now that you can fill in about their CEIP program, and there's some questions regarding that on there, so I can share the links with you all after.
Awesome. And if you do have questions that pop up later, you can email me directly at shannon@abmunis.ca, or if you have just like general CEIP contractor questions, you can email that at any time, contractor@myceip.ca. Also, I love phone calls, so call me. You don't have to wait for like a weird answering service, or like, it's just me on the other line. So.
Awesome. Well, thanks, everybody. I'm gonna open up, you don't have to do it this exact time. I will open up my Slido again. I do have a survey in there. I appreciate if you can take some time to fill it out. In the meantime, I said, I invite everybody to wander over to have a look at the walls, engage with Steve, engage with Chelsea about the wall assemblies. We have a Larsen Truss retrofit example over there that if you want to go and like get hands-on with an example of one. And yeah, we're just gonna be in, take the time to talk to each other, have a look at some of our other retrofit examples. Yeah, I really appreciate everybody coming this morning. Please eat all of our snacks. And take some time, talk to Tim about Retrofit Canada and the good work that they're doing. Because it's really engaged with exactly the kind of stuff you guys are working on. Oh, do I have? He's like way ahead of me.